Hello dear students, welcome to IMS Academy. So dear student, we are ready here to discuss the detailed analysis of Civil Engineer GATE 2023 exam. So dear student, if you have appeared for the exam, then just share the questions also, whatever the memory based questions you are able to remember, just share. Even our internal mentor, that is Ankit Dongriwal sir, also has appeared for today's forenoon session, so that he will provide us the memory based questions first. So whatever the data he has provided till now, accordingly my dear student, first of all we will have a discussion on the total number of pattern of questions. Okay, as you all know that in the GATE we are having a 3 pattern of questions: MCQ, NAT and MSQ. So first of all, just share the link of this session so that maximum students will get informed that IMS GATE Academy going to provide a detailed live analysis as well as detailed solution of GATE 23 exam Civil 1, that is forenoon session. So total number of MCQ questions were 35. 35 questions are MCQ, where we have a negative marking. But for numerically entry type of question, if I talk about, we have 21 numerically entry type of question, and you know very well here we don't have any negative marking, but at the same time we don't have a scope of option elimination because there is no options are. And 9 questions are MSQ, that is multiple select question. It may confuse sometime that which option is correct and how many options are correct among 4. So first of all, student, I would like to invite our next civil mentor. Sorry. So before that, student, I just want that once our faculty member will solve the technical problems here, before that at least you need to share this session so that maximum civil aspirants across India will get benefit from this detailed live analysis. So now I would like to invite faculty Mr. Sandeep sir, and he will have some question, that is memory based question, shared by your internal mentor only, that is Ankit sir. Okay guys, so now my first question to you, Sandeep, you can come.
Yes, sir.
According to you, whatever questions you have seen till now, I think 3-5 questions you have seen. So on the behalf of that, can you please comment on the difficulty level of today's exam?
Really, I'm very happy that the students of IMS will be very happy, sir.
Okay.
Because we have gone through our internal team preparation,
Yes.
and the questions came from our notes. This is 100%, sir.
Okay.
I'm not telling anything false thing. You can check our notes as first page. I'm really excited, and today I'm very happy that all the students will get very good success, especially from IMS. And one more thing, students, whatever the questions you have learned in the previous GATE questions, we have observed that those are the questions, underlying concept is same, sir.
Okay, so next over to you. You can start the questions.
Thank you, sir.
So how many subjects questions you have picked?
Sir, I have taken
Geotech?
the geotechnical
Okay,
subject.
very good. You can start with Geotech. Okay, over to you.
Thank you, sir. Thank you. Students, welcome to IMS Gate Academy. Here I would like to explain you some of the geotechnical questions which I have observed. This is the first question which I am having. They have given the values of specific gravity, students. They have given the values of specific gravity is given as G is equal to 2.6. Okay. Degree of saturation is given as 0.5. And remember, water content is given as 0.15. So this is a very simple question, my dear students. They have given G is equal to 2.6, that is the specific gravity, and the degree of saturation is 0.5%, 0.5 or 50 percentile, and water content is 0.15. My dear students, whenever they have asked this question, the relationship between void ratio, water content, and specific gravity and degree of saturation. If you see here, when you see the relation between void ratio, water content, and specific gravity and degree of saturation, this is the quite first and foremost formula which we derive in the properties of soil. And I told so many times in the class as well as in the offline classes, remember the properties of soil, the basic question will be coming. So here they have asked you the void ratio. So here they have asked you the void ratio. So the data, everything is given, my dear students. The data, everything is given in this here. So water content is how much here they have given as 0.15, and the specific gravity is given as 2.6, and calculate the degree of saturation is given as 0.5. So my dear students, whenever you solve this, you can easily solve that and with the calculator, and you will get a void ratio of 0.78. So please remember for the coming session also, this relation void ratio is equal to water content to G upon SR is the basic formula. Coming to the next question, see here they have given you a question in the shear strength concept. This is also a simple problem, my dear students. They have given a problem on shear strength. So you know already, if a graph is drawn between shear strength and effective stress or normal stress, this is, we call it as cohesion. We call this as cohesion. And from the straight line equation, you know y is equal to mx plus c. You know the shear strength is equal to c plus sigma tan phi. But here the given data is normal stress is given as, my dear students, 50 kilopascal. What is the normal stress given? The normal stress is given as 50 kilopascal, and the shear strength is given as 35 kilopascal, and they are asking the value of phi or angle of internal repose or angle of internal friction. The hint they have given it as sandy soil, which I have been telling you in the class for so many times, my dear students. The sandy soil or gravelly soil, if you have these soils, my dear students, sandy and gravelly soils are cohesionless soils. So remember, my dear students, when you talk about sandy or cohesionless soils, C will be substituted as 0. C will be substituted as 0. By using this generalized equation, here the shear strength is 35 kilopascal. That is equal to, what is the cohesion? Cohesion is taken as 0, and the normal stress is given as 50 kilopascal into tan phi. On solving this, you will get tan phi is equal to 35 upon 50, and the value of phi will be taken as 34.99 degree, or approximately you can write it as 35 degree. I hope this solution is clear for you. And remember, my dear students, whenever we are having a shear strength equation, in case of cohesionless soils, the graph will look like this, because there is no cohesion, or these cohesionless soils are observed in which type of soils, my dear students? These are observed in only in the gravel or sandy soils. I hope this solution is clear. Now coming to the beautiful problem which I have been explaining you so many times. So remember, my dear students, there was a surcharge. So students, there was a surcharge given in the problem is 20 kilopascal. And remember, I'll show you the shortcut how to solve this problem also. And here the width is 3 meter, and the given data gamma is equal to 18 kilonewton per meter cube. Okay, and here the phi value is given as 32 degrees. Okay, my dear students. And we have another layer which is of 4 meter, and gamma is equal to 19 kilonewton per meter cube, and gamma is equal to 19 kilonewton per meter cube. Phi is equal to 25 degrees and C is equal to 20 kilonewton per or kPa. Now remember, my dear students, as I am telling you from the starting onwards, they have asked you the problem active pressure at bottom. So whenever they ask you the active pressure at bottom, see, remember, I am giving you the elaborate solution and I am telling the short solution also. Whenever there is a problem of this nature, the first step is to find the coefficient of active earth pressure. And remember, they have asked the active pressure at bottom. They have asked the active pressure at bottom. As they have asked you the active pressure at bottom, you have to write Ka is equal to 1 minus sine 25 degree by sine 1 plus sine 25 degree. And remember, my dear students, if you waste the time solving this phi is equal to 30, it is completely waste of time. So I recommend you to take the phi value directly, that is 25 degrees, and you will get a value of 0.405. And remember, you know the formula for active pressure at bottom. If you see here, my dear students, what is the active pressure at bottom? See, there is an active pressure. What is an active pressure? When the wall is retaining, when the retaining wall is moving away from the backfill. So here active pressure at bottom is given by the formula Kr at any layer at Ka into sigma V minus 2C root Ka. This is the formula for active pressure whenever there is a cohesive soil. So here already you have calculated the coefficient of active pressure. But what is the other term you have to know? You know the cohesion value also. Cohesion value is given as 20. Now what is the formula? How to find out the vertical stress? I told you, my dear students, whenever there is a surcharge, surcharge will be uniform. Agree or not, my dear student? So here the surcharge is uniform. So it will be 20 at top as well as 20 at the bottom. And remember, my dear students, here gamma is equal to 18 kilonewton per meter cube, and here the depth is 3 meter. So you know the vertical stress is gamma into 18, that is equal to 54. How this 54 came? 18 into 3. And remember, my dear students, no need to do all these things also. For a shortcut, you can directly go to the bottom and you can write here. What is here? Gamma into 4, that is 19 into 4. This value will be equal to 76. So here it is 76, here it is 54, and here it is 20. So the vertical stress at bottom is given by the value 150 kPa or 150 kilopascal or kilonewton per meter square. So my dear students, just apply the formula. It is a simple formula thing you have to do. So here you can write, my dear students, active pressure at bottom can be written as Ka into sigma V minus 2C root Ka, minus 2C root Ka. So here, what is the value of Ka? What is the value of Ka you got? The value of Ka is nothing but 0.405. The value of Ka is 0.405 and the value of vertical stress is 150 minus 2 into 20 into root over 0.405. So here we have these values. So my dear students, what will be the active pressure at bottom will be equal to 35.42 kilopascal. So whenever you are writing the exam, see, remember students, I will tell you the simple steps. Okay, whenever earth pressure problems are given, I will tell you the basic steps. You please follow these steps to solve any problem of earth pressure. The first thing is find out the coefficient of active pressure or passive pressure or at rest pressure. If they ask you active pressure, please calculate active. If they ask you passive pressure, calculate Kp. If they ask you at rest pressure, you have to calculate the at rest pressure. After finding these values, my dear students, calculate the value of vertical stress. Calculate the value of vertical stress. Sir, the value of the vertical stress will be complicated only in case of water table. Whenever there is a water table, vertical stress should be written as effective stress plus pore water pressure, because effective stress is same in all directions. Sorry, pore water pressure is same in all directions according to the Pascal's law. So here, after finding the vertical stress, you can find out the active pressure or passive pressure, or you can say at rest pressure. And remember, they can ask you, active pressure means the wall movement is away from the backfill, towards the backfill it is passive pressure, and when there is no yielding of soil mass, it is at rest pressure. After finding this, area of the pressure diagram, I am generalizing this problem, mama. Area of the pressure diagram will be equal to force. Area of the pressure diagram will be equal to what, my dear students? It will be equal to force. And the last one we have is the point of application of force. You can remember that the point of the application of force will be taken as centroid. I hope you can solve any gate question related to earth pressure. If you point of application of force is nothing but the centroid. I hope this solution is clear, and students who are following the afternoon session, please remember these 5 points. Any question can be asked. Okay. Let us move on to the transportation part, my dear students. Let us move on to the transportation part. So here, when I talk about the transportation, they have given you the question related to, the transition curve. So what is the problem with transition curve? So we here, when I talk about the length of the transition curve, when I talk about the length of the transition curve, you should be very clear, my dear student. So what is the formula for length of transition curve is, we have different formulas. LS is equal to, length of the transition curve is given by V cube upon C into R, where R is the radius, V is the velocity in meter per second, and C is nothing but the jerk or rate of change of acceleration. So here, my dear students, they have given you radius is how much, sir? Radius is given as 300 meter. Radius is given as 300 meter. And the velocity is given as 15 meter per second as per the given data. And they have given you the cohesion. Cohesion is given as 0.75 meter per second cube. They have given you this data. So here, what is the length of the transition curve? They have asked you. So my dear students, why I have written this formula is, we have other formulas also. When we talk about the length of the transition curve, you have En plus W plus We, or you also have the formulas of length of transition curve is equal to 2.7 V square upon R. But remember, all these are the empirical formulas, and this formula is, this is an empirical formula, and this is the formula which is applicable in case of super elevation or extra widening. So whenever you have given this formula, the length of the transition curve, here the velocity is given as 15 meter per second. So 15 whole cube, and the rate of change of acceleration. Actually, my dear students, if the rate of change of acceleration is not given, usually it is taken as 80 upon 75 plus V. 80 upon 75 plus V is nothing but the rate of change of acceleration. That V is in kilometer per hour, but here they have given you directly. So 0.7 meter cube, and the radius is given as 300 meter. So here we know that the length of the transition curve will be equal to 15 meter. So the length of the transition curve will be equal to 15 meter. So students, if you really like this solution, please share this session, and it would be helpful for the upcoming session students who are attending. So just stay tuned. Okay. Meanwhile, you can comment anything. Okay. Students, if you have any questions or anything, you can ask me in the doubts. So what I have observed here is, in geotechnical we have seen questions. In geotechnical we have seen almost 17 marks. If you see the last minute strategy, Sir, if you see the Geotech strategy, what I would like to tell you here is, there is almost 17 marks, my dear students. So why they have given, I told you in my last minute strategy also. If you see the last minute strategy also, my dear students, the first subjects which I am going to tell you, Geotech, environmental, transportation. And remember, my dear students, when I talk about geotech, environmental or transportation, remember that when I talk about these three subjects, we have seen again they are 40 marks, my dear students. That is the beauty of these three subjects. And remember, my dear students, believe my words, believe my So believe my word, students, when I talk about the geotechnical, have been telling you so many times, my dear students. See, if you see my last minute strategy or telegram channel, I have told so many times, students, you will be getting a question from properties of soil and also only from the formulas. So students, the paper seems to be easy to moderate. That when the paper is easy to moderate, that time you should be very cautious. So please understand here, when you are preparing for the next year also, I suggest you to go through the previous gate questions, the question booklets. Sir, in IMS Gate Academy, we have an extraordinary team, especially for civil engineering. We are coming with the exercise books. We are coming with the standard reference books like gate question booklet for each one. So here I have told you also, when I talk about the properties of soil or in the class, my dear students at Jayanagar, I have told so many of my students, if anyone is there in the live, they can easily comment. How many times I have told you that there will be a question from properties of soil and earth pressure. So the questions are very easy. But in the afternoon session, now I am predicting there can be a question in earth pressure related to the tension crack depth, my dear student. So when I talk about the earth pressure, I am going to discuss about the tension crack depth. See, remember, my dear students who are giving the exam at 2 o'clock, it is my sincere guess. You can say it's my guess. Tension crack depth, critical hydraulic gradient, and also you have to think about the critical height. So these things, properties of soil, these topics you should be very clear. Yes, Krishna, hello sir. If you have any query, you can. Ankit, what is the next step? And coming to the next subject also, sir, in transportation also, I have been telling you in the class also. Transportation, if you see our last minute strategy, if you see the geometric design, sir, I have told in the class very clearly what is the formula, for transition curve. That is the same question we are expecting, sir. That is the same question we have expected. So if you have any questions, meanwhile you can comment in the comment box. I'll be explaining you, Amma. If you have any questions in the comment box, please comment in the comment box. If you have any other questions, Ankit, if you have any question, you can just write in the comment box and I will be explaining straight away. If you have any question in soil mechanics, please let me know. I will be writing the question in the, I will be explaining here itself. And remember, my dear students, in hydrology and irrigation, we have a question from infiltration. So students, our next faculty, Madam Priyanka Madam, will be taking care of engineering mathematics. Please try to share this session, and we are really excited to see the success of the IMS students and all the GATE aspirants. So please stay tuned and share this session. Thank you.
Hello everyone, welcome to all of you. Yes, okay, so I hope you guys are ready with the solutions. Okay, yes, I can see the comments also. So hello everyone, I hope your paper was good. Now I'm having few questions of engineering mathematics. Let's start with the questions. So dear students, as of now, whatever the questions I'm having, according to the questions, the level of engineering mathematics is again very simple. Okay, so let's start with the very first question. We are having the first question. This was an NAT. Okay, and the question is from the differential equation, very simple question of differential equation. One differential equation is given to us. So given a differential equation dy by dx plus, given the differential equation dy by dx plus alpha xy equals to 0. This is the differential equation. Okay, and with the initial conditions, we are having some initial conditions also. With the initial conditions x0, or let me write down, at x is equals to 0, y equals to 1, and at x is equals to, okay, and at x is equals to 1, y is equals to 0.8. Okay, directly we can write down. Then it is asking about the value of alpha. Then we need to find out the value of alpha, what it will be. So guys, had you approached this? Had you approached it? So this is a very simple question. This is a question of variable separation method. We can easily solve this one. So let's write down the solution. We are having the equation as dy by dx plus alpha xy. We can use here the variable separation. So I can write down the equation as dy by dx is equals to minus alpha xy. Now we can just separate the variables. So y terms we can just write down here, and the terms of x we can write down here. Now by integrating both the sides, we can solve the equation. So when I will solve by integration both the sides, it will be log of y or ln of y, natural log, minus alpha x square by 2 plus c. Now we are having the initial conditions. With the help of the both initial conditions, we can find out the value of constant. So yeah, very good. So we can find out the value of constant. First is at x is equals to 0, y is equals to 1. At x is equals to 0, y is equals to 1. When I will approach it, it will become ln y, which is 0. X is already 0. So we can approach from here that the constant c will be 0 beta. So we can write down the value of constant c, which is 0 already. The first thing is clear. Now y is equals to 0. Okay, so for x is equals to 0, y is also 0, isn't it? The condition for x is equals to 0, I am having the data in which it is written for x is equals to 0, y is equals to 1. Let me check from here only. So when we will go with the next at x is equals to 1, y is equals to 0.8. When we check from here, at x is equals to 1, y is 0.8. So when I will approach, it will be ln of 0.8. Okay, and when we will use here, it will become y, so minus alpha by 2, and the constant is already 0. So we can approach from here the value of alpha, which is minus 2 into log or ln of 0.8. When you guys will solve this one, the result will be 0.4483. So we can solve the value of ln 0.8, and then we can multiply with the minus 2. So the result will be positive, and the result will be 0.4463. 0.4463. If the question is like this one, we are having these data, so I am solving with the help of these data. So this is a numerical answer type question, and we can solve the solution. And the answer of alpha, it is asking about the value of alpha, hence the value of alpha will be 0.4463. Okay, Now one basic question is from probability also we are having. Let's approach to that question also. If as I'm telling you, the datas are memory based, so if the datas are correct, then we are approaching the question according to the datas only. So this is given to us, it is given to us the probability for event A, which is 0.5, and probability for event B, which is 0.8. Okay, and it is asking about the probability of at least one of them. Probability of at least one of them. So guys, had you approached the question and yes, then please confirm about the datas. Okay, so we can solve the question as this is a very simple question. We used to solve the concept of probability of at least. As we know very well, probability of at least is nothing but 1 minus probability of nothing. So we can go in this simple manner, as we know very well, and we learned so many times for this concept. Probability of at least is nothing but 1 minus probability of nothing. So I can use here this concept and I can solve the question accordingly. So if I will go with the required probability, it will be 1 minus nothing. Nothing means I don't want either A and B, so I don't want both the things. So from here we can find out the as we are having the probability of having event A. If I will find out probability of not having event A, it will be 1 minus 0.5, again 0.5. Similarly, if I am having probability of event having a probability of event B is 0.8, then if I want to find out probability of not happening the event B, it will be 1 minus 0.8, so it will be 0.2. We are having both the things and we can approach accordingly. So we can write down the required probability, which is probability of at least one of them will be happen. So we can approach the question as 1 minus 0.5 multiply with the 0.2, and when I will solve, the result will be 0.9. So simply we can solve the questions accordingly. Right guys, so you guys can only give us the correct data, or you guys can only confirm with the data, okay, because you guys appeared in the exam. So that's why we are approaching these questions. So right now I'm having 2 questions. Okay, let me find out more questions for you, and whenever I will have, I will come live again. So stay tuned to our channel. Okay, I will come with the more questions of engineering, mathematics and general aptitude both. Okay guys, so just hold on, few technical questions will be there in the lineup for you guys. So just hold on, just enjoy the solution of technical questions also. Okay, thank you.
So welcome back my dear students. I hope you have enjoyed the civil engineering paper. As promised in the classes, all the questions that you have seen for civil engineering forenoon sessions are covered in the classes in our classroom program. I hope you might have enjoyed by attempting the civil engineering paper. My dear students, I have told you for repetitive number of times. You need to read it very crisp, very precise, but you have to read it for multiple number of times. Let me start with one of the questions which was asked from strength of material. It was one of the easiest question. Just only thing is if you have understood the question properly or not. So question says that you have a simply supported beam. This is your simply supported beam. For this simply supported beam, the moments are applied at a distance of L and L. So this is a distance of L, again you have a distance of L, and again you have a distance of L. So the moment is applied over this beam, and it is again a multiple select question where more than 2 options are correct. It is a multiple select question where more than 2 options are correct. Option A says that shear force is 0 everywhere. Shear force is 0 everywhere over this beam. Option B says that bending moment is 0 everywhere over the beam. Bending moment is 0 everywhere over the beam. Option C says that support reaction is 0. Support reaction is 0. Support reaction is 0. And last one is option D is your deflection is 0 everywhere. Your deflection is 0. Deflection is 0 everywhere. Right? Now just look into this beam. Such a easy question to tackle. In this question, the only thing is what you need to do is, first of all, find the support reaction. If I name the support as A and B, in order to calculate the support reaction, I need to take the summation of moment about point A to be 0. So M in the counterclockwise direction, so minus M plus RB into 3L is equal to 0. So this RB is the support reaction. So RB into 3L is equals to 0. From here, I got the value of RB as 0. I got the value of RB as 0. So RB comes out to be 0. If RB is 0, taking summation of vertical forces to be 0, so RA plus RB has to be 0. So RA plus RB has to be 0. Here RB is 0. So from here I can very easily say that RA is also 0. So both of my support reaction is 0, right? So option number C is correct. Both of my support reaction is 0. Now talking about how to plot the shear force diagram, okay? So I'll just draw the beam again. So this is my beam. Right? This is the moment M. This is again the moment M. And the length is L, L and L. There is no support reaction at A and B. There is no support reaction at A and B. So if I need to draw the shear force diagram, the shear force diagram will be a straight line having 0 magnitude over the entire span L, right? So this is your shear force diagram, and your shear force value is 0 in the entire span of the beam. This moment will not going to change the ordinate of the shear force diagram. The ordinate of the shear force diagram is only changed by the vertical loading. It can be either a point load or a UDL or a UVL, right? So this is your shear force diagram. So shear force is 0 everywhere over the beam. Talking about the bending moment diagram, so this is the reference for bending moment diagram. Since there is no support reaction, so up till this span, for 1/3 of the span, for this span, initial span, there will be no bending moment. Then you have a anti-clockwise moment M acting over it. So this anti-clockwise M will going to shift down the bending moment by the magnitude of M, right? This will going to continue, and at this point where the clockwise moment is acting, you need to move up by the amount of M, right? So this is, you need to move up by the amount of M, and this is your bending moment diagram, which is negative at this part, and you can clearly see that your bending moment is not 0 over the entire span of the beam. You have some value of bending moment in the middle span where the anti-clockwise and the clockwise moment are acting over the beam, okay? Now for this question, as you can see in option A, your shear force is 0, so this option is correct. So option A is correct. But your bending moment is not 0 over the entire span. So option number B is not correct, right? Now talking about the deflection is 0 everywhere. As you can see here in this bending moment diagram, due to this bending moment, there will be some deflection over the beam. So you can clearly identify that the deflection is not 0 over the entire span of the beam. So for this question, option number A and option number C are correct, where shear force is 0 and your support reaction is also 0. Just look into the question, how easy the question was, right? I was constantly telling my students in the classes that for GATE examination, the only thing required is your technical aptitude, and it has proven now with the paper of civil engineering, right? One more thing I would like to add here, I have told my students that this time the paper will be more application based. As you can see here, there is no formula based question. All the questions are concept based, right? You have practical application for all these questions which are there. So this is how the question is framed for this year civil engineering examination. Now moving on with the next question. So again I have the question of strength of material. I got the data like this. So there is one beam, there is one hang like this, right? And the diameter of this hang is, this D1 is 100 mm. This diameter is 100 mm, right? Next, I have one more hang like this, and this hang has a diameter, this D2 has a diameter of 50 mm. This D2 has a diameter of 50 mm. Two external loads are acting over this hang, number 1. So these two external loads of 100 kilonewton magnitude are hanging over the beam. This is 100 kilonewton magnitude are hanging over the beam, and you have one more load of 50 kilonewton hanging at the base of this overhang, right? This hang. You need to find the value of maximum tensile stress which is developed in this sections, right? So basically from this point, I'll just name it as, this is point A, this is B, this is C. As you can see that these are the prismatic sections. So the value of stresses is constant from C to B and also from B to A. Due to change in area, there will be two different values of stresses in both these members, right? There will be some value of sigma 1 in the upper member and the value of sigma 2 in the lower member. Let me calculate sigma 2. Let me calculate sigma 2. Sigma 2 is nothing but load, that is P1. I'll name it as P1. This is 50 kilonewton P1, right? P1 divided by area. P1 divided by area. So nothing but this is pi by 4 into D2 square, right? So P1 is given as 50 kilonewton. So this is 50 into 10 raised to power 3 divided by pi by 4 into D2 is 50 mm, right? So this is 50 the whole square. When you calculate this, you will find that, I guess this is the square or a circle. Just confirm it once. Is it a square or a circle? Just confirm it once. The cross section of this is a square or a circle? Just confirm it once. The cross section of this is a square or a circle? Just confirm it once in the comment box. Is it a square or a circle? Just confirm it once. Okay, let me assume this as a square, right? Let me assume this as a square. So this is 50 by 50. Let me assume this as a square. So here the value of stress comes out to be 20 Newton per mm square. I am assuming the cross section to be square. I still don't have the exact data. The cross section I am assumed to be square. The cross section is assumed to be square, right? So sigma 2 comes out to be 20 Newton per mm square. Now talking about sigma 1, the total load that will be acting will be 100 plus 100 plus 50. So the total load acting for this sigma 1 will be 250 kilonewton. So sigma 1 is P1 dash divided by D1 square. So P1 dash is nothing but 100 plus 50 divided by, so this is kilonewton, so 10 raised to power 3 divided by your cross section area, that is 100 into 100. So this comes out to be 25 Newton per mm square. Right, as you can clearly see, the value of sigma 1 is more than sigma 2, right? So the stress for this member, AB is more than stress in the member BC. So hopefully you have marked this correctly. Okay, so hopefully you have marked this correctly. So I am assuming this cross section to be square, and okay, my student has confirmed that it is also a square, right? So this is again a question from SOM, from the simple stresses. These are the simple questions, right? Now moving on with one of the questions that was directly asked from my notebook, and that is a question from proximate analysis of the environmental engineering. I have told you that there are two major areas in environmental engineering from where the questions can be framed from solid waste management. First one is the proximate analysis, and second one is the sanitary design of sanitary landfill, right? So we expected this question, and we got one question of environmental engineering. So question says that you have a solid waste. So this question is of environmental engineering. Question says that you have a composition of solid waste. So you have components. You have components of solid waste, and components of solid waste include food waste, it include paper waste, then you have cardboard waste, then you have your plastic waste, and lastly you have your other types of waste. The percentage by mass is given as, so percentage by mass it is 20%, 45%, 20%, 45%, then you have 5%, then you have 10%, then you have 20%. You are given with the calorific value of these waste. So calorific value of these waste is given in megajoule per kg. Calorific value is given in megajoule per kg. So this is 4.5, this is 16, then you have 14, then you have 32, then you have 8, right? Along with it, you are given with the moisture content of this solid waste. So just confirm me once, in this question, we need to calculate the energy content on dry basis in megajoule per kg or megajoule per 100 kg. Just confirm me once, it was megajoule per kg or megajoule per 100 kg. So if it was megajoule per kg, what I will do is, I will first off assume, let us assume total weight, of solid waste is equal to 1 kg. I have assumed the total weight of solid waste to be equal to 1 kg. If the total waste of solid waste is 1 kg, the mass of the food waste that will be present will be equal to 0.2 kg. Similarly, the mass of the paper waste will be 0.45 kg. Mass of the cardboard waste will be 0.05 kg. For plastic, it is 0.1 kg, and other it will be 0.2 kg, right? So what I will do is, so I have assumed the total weight of the solid waste as 1 kg, and corresponding to this, I'll calculate the energy content. I'll calculate the energy content of the individual waste, right? So what I will do is, for 20% by mass of the paper waste, the weight in 1 kg will be 0.2 and 0.2 multiplied by 4.5, right? Similarly, for 45% by mass of the paper waste, it will be 0.45 in 1 kg. It is 0.45 in 1 kg multiplied by 16. Similarly, for cardboard waste, it will be 0.05 multiplied by 14. For plastic waste, it is 0.1 multiplied by 32. So this is the energy content, right? Last one is the other type of waste, which is 0.2 multiplied by 8. So this is the total energy content of 1 kg of the solid waste burnt. This is the total energy content. If you calculate this, you will get the answer as 13.6 megajoule per kg. So this is the total energy content of 1 kg of the solid waste. But this is not asked. What is asked is energy content on the dry basis. For energy content on the dry basis, I need to have the moisture content for the solid waste, which is directly mentioned as 26%. So the moisture content of the solid waste is mentioned as 26%, right? So using the direct relation, energy content on dry basis is equal to energy content on discarded basis into 100 upon 100 minus moisture content percentage, right? So energy content on the discarded basis is 13.6 megajoule per kg. So this is 13.6 megajoule per kg multiplied by 100 divided by 100 into 100 minus 26%. So you can calculate this, you can calculate this to have the final answer. You can calculate this to have the final answer for this question. Just calculate this. Just calculate this for the final answer. So this was the energy content of the solid waste on the dry basis. This is 18.378 megajoule per kg. So this was one of the easiest question, right? Only thing you need to keep a check that you need to calculate the megajoule per kg, right? So what is the basic problem that student is having is they are assuming the total weight of the solid waste to be 100 kg. Then whatever the energy content they are calculating, this energy, total energy content is megajoule per 100 kg of the solid waste burnt, right? But you need to calculate the energy content for 1 kg of the solid waste burnt. That's why you need to go with this approach. This is the direct question that I have predicted before GATE examination. You can just go to our YouTube channel and check for the strategic last moment strategy for civil engineering students, and you will clearly find that I have told very precisely that a question from proximate analysis will be there in your examination. So for now, these three are the questions that we have, and we will continue. My next faculty will continue from here onwards. Okay, please join. Please continue with the channel.
Hello guys, how are you? Hi everyone. So tell me, how was your paper everyone? Please tell me fast, how was your paper? Few questions already we have solved, right, from Geotech, from structures, right? So I came up with two questions from engineering mechanics, and that was what very basic questions, right? First question is from the T section, moment of inertia. Second is from the truss part. So questions were very basic, I would say, from the engineering mechanics topic, right? And in a meanwhile, if you have any questions, please mention your question in the chat box also, so that we'll provide the correct solution to you guys. Okay everyone, so we'll start with the next question guys. That is from the engineering mechanics, right? So actually they have asked a question from moment of inertia part, right? From moment of inertia T section they have provided. Right, see. So see everyone, please confirm me the data. This length was given as 40 and this was 50, right? And this length was given as 20 and this was 10. Okay everyone, tell me fast, this was the data, right? Right everyone, so this was the T section given to you, and you need to find out the moment of inertia about the centroidal axis. So in order to calculate the moment of inertia about centroidal axis, you need to first calculate what? The centroid only, right? So we'll first calculate the centroid part. Okay everyone, see how we'll calculate the centroid here. So actually it is a symmetrical case, and I've told you many times, whenever symmetrical case is there, one of the axis of symmetry will be what you can consider as what a reference axis here. So it is symmetrical about y-axis. So I will consider y-axis as my reference axis, one of the reference axis I can consider. And about the horizontal axis, you can consider in the bottom or top, it's your choice, right? Okay everyone, now see, let's suppose if I consider my reference axis horizontal like this in the bottom, right, like this I will consider. So what I will do, I will directly apply a formula here, so that I will get what? The y coordinate. Okay, I will get the y coordinate, x coordinate will become 0 because it is symmetrical about the y axis. Y coordinate I will find out here. First of all, this first part, that is what, 40 into 10. Then we need to take a distance from this reference axis. 50 plus 5, that is 55. Plus second part, 50 into 20. Right, and what is the distance from the reference axis of the centroid of this part? 25. Right, and what is the area? Area is what? 40 into 10, area of first part, plus area of the second part, 50 into 20. Right, so from this you will get the location of the centroid, right? Everyone please tell me what will be the centroid here. So I am having an answer here, 33 point. Please cross check your answer here everyone. 5714. Okay, so this was the centroid part. Everyone please cross check your answers here, right everyone? So this was the centroid. Now we have calculated the location of centroid. Now I will calculate the moment of inertia, area moment of inertia about the centroidal axis, right? So I will next mention the centroid here. Everyone please understand where it will be. See, it will be somewhere here. Right, so this is what distance we have calculated, 33.5714. Now total distance is what? 60. If I subtract the this value from the 60, I will get this value also, right? So if I calculate this one, this value comes out to be 26.4286. okay, 26.4286 it will come out. Okay, so this was the values. Now how to calculate the area moment of inertia? Just see everyone. See, in order to calculate the moment of inertia about the centroidal axis, see, this is my centroidal axis. So I will mention here, let's suppose xx I'm mentioning, This is my centroidal axis. This is my centroidal axis, right everyone? Okay, so this is the centroidal axis. About this axis I will calculate. First I will consider this part and then this part. So in order to calculate the moment of inertia, we will be using what? The parallel axis theorem, right? Parallel axis theorem we will be using here. Okay, so for the first part, okay, see, 40 into 10 cube divided by 12. This is the moment of inertia of this part about its own centroidal axis. But we need to calculate the moment of inertia of this part about this axis. So we will use parallel axis theorem. Okay, so for that we'll apply the formula of parallel axis theorem. What is the area? 40 into 10 into distance, right? Remember which distance we need to keep here? Distance of the centroid of this part from the centroidal axis, right? So what will be the distance? You need to subtract the 5 because the centroid will be what? At 5. You need to subtract 5 from this value. Okay, so it will be like this: 26.4286 minus 5 square. So this is the moment of inertia of this part about this centroidal axis. Now for the second part we will write like this. Second part will be what? See, 20 into 50 cube divided by 12 plus area 20 into 50 into distance. Now which distance we need to take? The centroid of this second part, that will be at 25, and this total distance is 33.5714. So we need to subtract that 25 value from 33.5714 minus 25 we need to do square. So this is the formula by which you will be getting the mass area moment of inertia of the T section. Very important topic, right? So if you put all those calculations here, if you put all those values, use a calculator, you will get the answer here. Okay, I think the value they have mentioned in centimeter, so accordingly answer will be centimeter to the power 4, right? Like this. So I am having the final answer here and I am mentioning the answer finally. Okay, see everyone, the final answer it would be like this: 468809.5237 centimeter to the power 4. Okay, please verify your answer here also, right everyone? I hope this particular solution is clear to everybody. So lot of time we have discussed this question in our classes also. See, when I started the centroid part, okay, first I will tell you to calculate the location of centroid. After that we have solved for many questions of moment of inertia, area moment of inertia. We have solved for T section, we have solved for I section, we solved for L section, various sections we have solved, right? So from that only the question has come. So it is what very easy question, just the calculation part you need to take care. This calculation part very important. Okay, which distance you need to keep here, which distance you need to keep here, right? These distances are what very important. So I hope this is what clear everyone. Now next we'll solve here one more question. Okay, next we'll solve one more question from the truss, engineering mechanics question only, but from the truss, right? Okay, see next question. Okay, this was the question, guys. Here roller support, here the hinge support was there, right? Very good afternoon, Krishna, very good afternoon. So this was the truss given to you, okay, and there was the members like this. There was member like this. Okay, now see everyone what they have mentioned. This distance, this each part of the truss is 3 meter. Okay, they have mentioned this distance as 3 meter. Three meter. Okay, and load was given here. Load was given, right? see everyone, how the load was given. Here it is like 20 kilonewton. Okay, everyone please cross check the question data as well, because this was question given to us from the student only. So just cross check the data also. Thank you, Pragya, but please cross check the given data. If there is any problem, any error is there, you can mention. Okay. So this was the 20 kilonewton. Every load was given as 20 kilonewton only. Okay, and see, a lot of question we have solved from the truss analysis, right? And I've told you, always use method of section. Okay, method of joint we have discussed a lot, but I always tell you, use method of section only, because it will take only few seconds or few time only, right? It will consume minimum time, and you will get the correct answer also, right? So it will consume minimum time. That's why I always prefer to use what? Method of section. That's what I've told you in the classes also, right? So always use method of section here. Okay, and see, this was the 3 meter, and this distance was also 3 meter. Okay, I hope the data is clear, right? Data is correct, yes or no? Please guys confirm. So this was a 20 kilometer like this. Okay, now, and what they are actually asking. So they was asking the force on this member. Force on this member they were asking. Okay, they were asking the force in this member. So I will directly mention. Okay, just a second. So they were asking the force on this member. So I will mention here as a question mark on this member. So what we will do, we will apply what? Method of section. A section I will use to cut this truss. So it will be divided into two parts, right? So how it will be divided? See, it will be like this. It will be like this. Yes or no? So this was the truss, the left side of part of the truss. Force is what? Like 20 kilonewton. Right. Now, obviously a reaction will be there because there is what? Hinge support. Now, looking at the load distribution here, it is symmetrical loading. Without doing any calculation, you can easily calculate the reactions. Without doing any calculation, you can calculate the reaction at the supports because of the symmetrical loading case. So what will be the reaction? 50 only, right? Because the total loading in the downward direction is what? 100, and because of the symmetrical loading, here the reactions will be what? 50-50, right? So here the reaction will be what? 50 kilonewton, right? Okay, now, so they are asking the force in this member. So this was the force they were asking. See, this member length is 3 meter, this was 3 meter. So obviously this angle will be what? 45 degree. Basic mathematics you can apply here, right? So 45 degrees there, they are asking the force in this member. So whenever we are applying the method of section, remember it is a non-concurrent force system, and you will have three equations to solve any question of truss with method of section. Summation of force along y direction 0, summation of forces along x direction 0, and moment about any point you can take. So these are the three equations that you can use in order to solve this question. But remember which equation we will be using here. So consider that we need to calculate the value of force F. So which equation will help us to calculate this question? See, this force will have a component in vertical direction. See, remember this force is also unknown to us, this force is also unknown to us, but they are asking this force. So we will be using that equation in which these forces will not be there. Okay, otherwise we need to solve those values also. So we'll be using that equation in which this horizontal forces will not come in our equation. So I will be using summation of forces along vertical 0 because these forces are in horizontal, and definitely they will not come in my equation, summation of forces along vertical direction 0. So I will be using this equation. Which equation? Summation of forces vertical 0. This equation I will be using. Right? Now, while using this equation, remember, so 20 downward, 50 upwards, right? And the vertical component also in downward direction. So 50 upwards, minus 20, okay? And minus F sine 45 equals to 0. Clear? So from this equation, see, what is this value? 10. So you will have this F sine 45 equals to 10. What is sin 45? 1 by root 2. So what you will get? 10 into root 2 as the answer. Okay. You will get the answer as what? F equals to 10 into root 2 kilonewton. So this was the answer. Okay. So never worry about the direction. Okay. If you are solving and finally answer is coming in positive sense, it means whatever direction you have assumed, it was correct only. Remember this point, everyone, please remember this point. Whatever direction you are assuming, if the final answer is what positive only, it means direction assumed by you was correct. If the negative comes in the answer, you will say just change the direction. Opposite to that direction will be the correct answer here, whatever you have assumed till now. So I hope this particular question is clear. So this question was very easy from the method of section. Don't use the method of joint. Always use method of section. I'll see lot of time I've discussed this thing in the class. Okay, and we have solved so many questions from the method of section so that everyone will be confident enough to solve such questions, right? So I hope this question is clear. Now next faculty will come and he will discuss the questions from the rest of the subjects, right everyone? So please stay tuned and please share the session with your friends, and if you are getting any question, please post in the comment box or in the chat box so that we will provide the correct solution to you, right everyone? So the next faculty will come in few seconds.
Hello, my dear students. Now we have a question from, as usual, we have a question from RCC. Okay. The question here is in RCC. See students, it's a very, very basic question. They have asked, what is the maximum compressive strain in concrete? I told in the last minute strategy also, what is the maximum strain in concrete, my dear students? This is according to the limit state method. The maximum strain in concrete is given by the formula 0.0035. It is a standard value and this value is given from the code. So 0.0035. And they ask you what is the maximum strain for the steel. They have asked you another important thing. They have asked you what is the maximum strain in steel. So the maximum strain in steel is given by the formula. You might have seen this. The maximum strain in steel is 0.87. The maximum strain in steel is given by the formula 0.87 Fy upon Es plus 0.002. This is the maximum strain in steel. So remember, my dear students, in RCC, how the strain is going to distribute is, the strain is going to, if you see the strain is going to vary in the linearly. So what is the maximum strain in compression side is 0.0035 and the maximum strain in steel is, you can say 0.87 Fy by Es up plus 0.002. Am I correct? Very basic question, very basic question. So they have asked you, the formula here is 0.002, the maximum strain is 0.002 plus 0.87 and they have given yield stress also. Sir, they have asked for grade of Fe415. They have asked the yield strain of Fe415 grade of steel. So they have given you the value of Fe415 and you know the value of Young's modulus of steel is 2 into 10 power 5. So my dear students, you can ask me how this graph, how this formula has came. If you, just to give you a clear idea, I am just giving this information also. If you draw the graph between stress and strain, if you draw the graph between the stress and the strain, the graph of the stress strain curve of steel will be in this way. So usually this is how we do in SOM. The same thing also it will be there here like this. We have the graphs in this way. So actually the yielding point you don't know. For that, to find out where exactly, means up to proportionality limit only, the stress and strain will be directly proportional. But after the yielding point, they are not linear. For that, we have drawn an offset at a value of 0.02. That's how the 0.02 value came, and this is the basic equation from the limit state method design, and you have the strain is equal to 0.0038. So the options, if they have given you 0.0035 and option 0.0038, this is the maximum strain in steel and this is the maximum strain in concrete. I hope this solution is clear for you. Now coming to the next question, my dear students, they have asked you another important question. So they have given you in soil mechanics. In soil mechanics, as usual, they have given you the question from pile foundation. Actually, my dear students, when I talk about the pile foundations are used when the subsoil is very weak or loose. In this case, usually the pile foundations are existing. So what is the given data here is, the given data is given as number of piles is equal to 9, and they have given you the dia of the pile is 0.3, and they have given you the length of the pile is 7, and they have given you it is a cohesionless soil. So C is equal to 0, and phi is given as 32 degrees, and they have given you the efficiency, the group efficiency is given as 60 percentile, and they are asking what is the spacing. So my dear students, in this case, the group efficiency is given by the formula 1 minus theta by 90. This is a very important formula, and previously they have asked this in the previous gate questions also. N minus 1 into M plus M minus 1 into N. So upon, if you divide it by M, and this is the formula, my dear students. Here I have given you the formula. The group efficiency is given by the formula 1 minus theta by 90 degrees N minus 1. Now you can ask me, sir, what will be the value of theta? You have to find out the value of theta. So here the group efficiency was given as 60 percentile. So you can take the value as 0.6. Here you can take the efficiency, group efficiency as 0.6. And remember, we have to find out the theta. And they have given, see, the number of piles are given as 9. So here what I would like to tell you, my dear students, here N and that N is different. So whenever there is a square pattern of piles, so there are 9 piles means the piles will be distributed in this way, my dear students. The piles will be distributed in this way. So here what is the number of piles in a row? What N indicates is, N indicates the number of piles in a row, that is equal to 3, and M indicates the rows. Are you getting, my dear students? Here N indicates the number of piles in a row and M indicates the number of rows. So here you can write simply, what is N minus 1? 3 minus 1 into 3 plus M minus 1 is also 3. So 3 minus 1 into 3 upon Mn. If you solve this equation, my dear students, you will get a value of theta. What is the value of theta? Theta, you will get a value of 27 degrees. But remember, when we discussed this problem in the class, I have told you clearly, tan theta is equal to D by S. Tan theta, or they remember, you might have remembered in this way. Actually, some people might remember, theta is equal to tan inverse of D by S, where D is the diameter and S is the spacing. So here what is the spacing you can write is, spacing can be written as D by tan theta, because they have asked you, tan theta is taken as 27 degrees, and you know that S is equal to diameter, spacing. What is S? They have asked the value of spacing S. So here diameter is given as how much, my dear students? They have given the diameter as 0.3 meter. So divided by tan 27 degrees. Upon solving this equation, you might get a value of 0.589 meter. I hope this solution is clear for you. Definitely it will be 0.589. So remember, my dear students, group efficiency. What is actually a group efficiency means? Remember, in a group there can be two failures. One is the individual failure and other one is the bulk failure. But what is a group efficiency means? It is the, you have this group. Actually, you might have seen group efficiency formula, Qg by N upon QUI. So this means it is the ratio of average load on pile group to the single isolated pile at which failure occurs. Or simply efficiency means output by input. As you are talking about the group, if you take n piles in a group, what is the individual carrying capacity of the pile in the group as well as the single isolated pile, how much it will consider. So the ratios is nothing but the efficiency of the pile group. So remember students, if you are helpful for this, please share to your friends. That will really help you. And I am excited to say that IMS Gate Academy provides you the offline coaching at Jayanagar, and we are trying to provide the hybrid model, and we are providing every day the online classes, and we are also the self-learning program. We had an extraordinary team, my dear students. Before moving that, we will discuss one practical question on transportation. Remember, my dear students, see, you are telling me, sir, did I promise you or not? Did I promise you or not? See, transportation question, students, I promised you in the last moment strategy. In the last moment strategy, I have told only one question in transportation, that you have to go through density and traffic flow and velocity. And it was posted 3 days or 4 days before in IMS Gate Academy, and the same question is there. And you can watch that video also, my dear student. So here the question here is, they have given you the question. They have given you a question like this, my dear student. So they have given you that there was a question given between velocity and density. And remember, my dear students, the velocity and density is going to vary. If you see here, the velocity and density are going to vary in which way? They are going to vary linearly. So here they have given you in the problem the velocity of VA, and they have given you this is KA, and they have given you velocity of VB, and they have given you the density as KB. So there was a graph between velocity and density, and the velocity and density graph, how it is going to vary. Remember, my dear student, the velocity and density graph is going to vary linearly. The velocity and density graph is going to vary linearly. And as I told you, the maximum flow, traffic flow, if you see here, when I talk about the maximum traffic flow, what I would like to tell you here is, maximum traffic flow is given by the formula VF, the maximum flow speed at half of maximum free flow speed into half of jam density. This we have seen. So maximum traffic flow can be taken as VF by kg upon 4. But remember, my dear students, they have asked you in this problem, what is the capacity of A and B? What is their ratio? So you can write the capacity of A and B as VA upon KA by 4 upon VB into KB upon 4. So if you see here, both the relations, both the KB, you can write here KB upon 4. So if you see, the 4 and 4 gets cancelled, you know that capacity of A upon capacity B can be written as VA into KA upon VB into KB. So remember, my dear students, whenever you are writing the GATE exam, as I told you, now or next year, whatever, remember, it is a classical problem. Q is equal to KB, or maximum traffic flow can be taken as Kj into Vf by 4. If you can remember these two formulas and the graph, this is a classical question in transportation, my dear student. And remember, my dear students, we have observed some question in the surveying also. So here, what is the question they have given you? Here I will just give you the insight of the question. They have asked that there is 2 stations, my dear student. There is a station at one end, okay? There is a station at one end, and there is a hill. Here there is a hill, okay? They are asking what is the RL at the top. They have asked you what is the RL at top, and they have given you this angle, my dear student. They have given you this angle, and this angle is given as how much, my dear student? They have given you this angle as 18 degrees 45 minutes, my dear student. So there is another station also. This is common question in trigonometric leveling. This is a quite common question. This is the question we can expect every year. Means usually in tachyometry or trigonometric leveling, this is the question. And there the line of sight is same. And here the angle is given as 12 degree 45 minutes. And they have given you, there is a benchmark here. So whenever there is a benchmark, definitely there will be a backside. Now whenever you want to find the The RL of the line of sight or the height of instrument is nothing but the benchmark. You can write here, this is benchmark, my dear student. So what will be the RL of the point P or Q or whatever? So here you have to just assume that this distance, you can assume it as some x. You can assume this distance as x. And remember, my dear students, the distance between these two is also given as 55 meter. The distance between these two stations, you can assume this as station A and you can assume this as station B. So what is the RL of the point P? So it is a very, very simple question, my dear student. So from the graph, if I take this distance as y, so you can write that tan 18 degrees 45 minutes is equal to 18x by x upon y. This is the equation they have, because it's a trigonometry. Tan theta can be written as opposite by adjacent. So here, so opposite by adjacent, I have written tan 18 degrees. Similarly, if I write tan 12 degree 45 minutes, okay, is equal to x upon y plus 55. So you can write x upon y plus 55. So because this distance, you have to calculate this entire distance, and this entire distance is taken as y plus 55. So if you calculate this, there is no point in solving y value, because he has asked the RL of P. That comes your common sense, my dear student. Because whenever they have asked you common sense, because in this case, see, here you can write RL of P. So RL of P can be taken as, if I take here RL of B plus backside, whatever the backside value they have given something value of 2.340 meter. So my dear students, if you solve this equation, okay, you will get RL of backside plus whatever the distance of x will give you the RL of P. So RL of B is given as 100 meter and the backside or height of instrument is taken as 2.3. So from this 2.34, if I add RL of B plus backside, that will give you the height of instrument, and whatever the x value, if you solve, I am getting roughly value of 139.63, even 138.7, 139.64. So if you got this, see, this is a simple question related to trigonometric labeling, my dear student. So my dear students, we are also have seen a questions in hydrology and irrigation also. The basic question from infiltration, that is phi index and W index, are also seen. So you can please stay tuned to this channel, and my colleague will also continue with the other topics. Okay.
Hello, my dear students. Hello, the voice is audible to you? Voice is audible. So we are come up with one more question from strength of material. So this is one of the question from strength of material. So this is a question from strength of material. So the question was little bit tricky, but the question was very easy. What the question is saying is, you are given with a stress condition like this. A stress block is given to you. And this stress block is inclined at 45 degrees. this stress block is inclined at 45 degrees, right? For this stress block, you are given with these stresses. So, this is given as 6 megapascal. This shear stress is given as 3 megapascal. Then you have the normal stress over this plane as 5 megapascal. The shear stress over this plane, is given as 4 megapascal. Then again this is 6 megapascal. And you have this 5 megapascal. And you have this shear stress over this plane as 4 megapascal. And you have again this shear stress as 3 megapascal. Now the basic confusion with the student for this question is, in this question you need to calculate the major principal stress, that is the value of sigma 1, right? You need to calculate the value of sigma 1. So most of the students, what they did is, they have directly applied this formula that sigma 1 is equals to sigma x plus sigma y by 2 plus under root of sigma x minus sigma y by 2 the whole square plus tau xy the whole square, right? Just clearly observe this figure, okay? For this figure, the stress which is acting in the y direction is perpendicular to the plane, right? So this is the stress in the y direction. So no doubt this 6 megapascal is my sigma y. And the shear stress acting on this y plane is my tau xy. So tau xy is given as 3 megapascal. So I'll write it down. Sigma y is given as 6 megapascal and tau xy is given as 3 megapascal, right? Tau xy is given as 3 megapascal. But this is not my sigma x. Sigma x has to be in this horizontal direction, right? This is the normal stress and the shear stress acting on an oblique plane which is inclined at 45 degrees with my xy plane. With my x plane, this plane is oblique by 45 degrees. So this cannot be taken as sigma x, right? I need to calculate the value. So the value of sigma x I need to calculate. This 5 megapascal is not the value of sigma x. This 5 megapascal is the value of normal stress which is inclined at 45 degrees to the plane of the x-axis. Similarly, this 4 megapascal of shear stress is the shear stress on the oblique plane which is inclined at 45 degrees with the plane of x-axis, okay. So this 4 megapascal and 5 megapascal, this 5 megapascal should be used to calculate my sigma x value, right? So this 5 megapascal is nothing but my sigma theta. So this 5 megapascal is nothing but the normal stress on an oblique plane. So my normal stress on an oblique plane which is inclined at an angle theta, it is given by sigma x cos square theta, sigma x cos square theta plus sigma y sin square theta plus sigma y sin square theta plus 2 tau xy cos theta sin theta, right? Cos theta and sin theta. So the value of normal stress on an oblique plane, I know it is given as 5 megapascal. It is given as, it is given as 5 megapascal. This is the value of normal stress on an oblique plane. So it is given as 5 megapascal. So I'll write it down. So this is 5, which is equal to sigma x I need to calculate, into cos square theta. So cos square 45 degrees. Next is sigma y. Sigma y is given to us as 6 megapascal. So sigma y is 6 megapascal. So this is 6 into sine square 45 degrees. Next, the value of tau xy. So the value of tau xy is given as 3 megapascal. This is the value of tau xy. It is the shear stress acting on the y plane, right? So this is the value of tau xy. So the value of tau xy is given as 3 megapascal. So substitute the value of tau xy. So 2 into 3 megapascal into cos 45 into sin 45. Into sin 45. So just do the calculation quickly. So here you have, so this is 5 is equals to sigma x. Cos 45 is 1 by root 2, so this is 1 by 2 plus 6 into sin 45 is 1 by root 2, the square will be 1 by 2 plus 2 into 3 into 1 by root 2 plus 1 by root 2 is again 1 by 2. So this 2 and 2 cancels out. This is 1 and 3 times, right? So from here you will get the value of sigma x. Just quickly calculate it. So this is 336. 6 minus 5. So this comes out to be minus 2 megapascal. So this sigma x comes out to be minus 2 megapascal. So the value of sigma x comes out to be minus 2 megapascal, right? Now I have all the values. I have the values of sigma x, I have the value of sigma y, I have the value of tau xy. So you can directly substitute in the formula for principal stresses for calculating the major principal stress. So the major principal stress sigma 1 is equals to sigma x plus sigma y by 2 plus, for major principal stress we add the both the terms, right? So it is plus under root sigma x minus sigma y by 2 the whole square plus tau xy the whole square. So this is the value of major principal stress. So I can write sigma 1 comma 2, it is plus minus first term and second term. We'll just substitute the values and get the values. Because for major principal stress, right, we need to check on the magnitude, not on the sign. That's why you need to consider both the terms. So we will consider both the terms. So sigma x is minus 2 megapascal and sigma y is 6 megapascal. So sigma x is minus 2 megapascal and sigma y is 6 megapascal. So divided by 2. So this is my first term plus minus under root of sigma x, that is minus 2 minus 6 divided by 2 the whole square plus tau xy. So tau xy is given as 3 megapascal. So tau xy is 3 megapascal. So this is 3 square. Right, when you solve this, so minus 2 plus 6 is 4 by 2 is 2. So this is 2 plus minus. So minus 8 by 4, so minus 4 the whole square plus 3 the square is equals to 5 square. So this comes out to be 5, right? So sigma 1 is equals to 2 plus 5, that is 7 megapascal, and I'll also calculate the value of sigma 2. So the value of sigma 2 comes out to be 2 minus 5, so this comes out to be minus 3 megapascal, right? So we need to only find the value of major principal stress. So major principal stress value is 7 megapascal. So for this question, sigma 1 is equals to 7 megapascal is the correct answer. It is the correct and the final answer. The only thing that will happen in this question is you can, in hurry, you can substitute the wrong value of sigma x. That you need to calculate. Okay, so this was the question from strength of material. Next question from environment. The question was very easy. The only thing is some data is required from your side. And question was, what are the waterborne diseases? Question was, what are the waterborne diseases caused by viral pathogens? Caused by viral pathogens. what are the waterborne diseases which are caused by viral pathogens? So this is again a multiple select question where more than one option can be correct. I'll just write down the options. So option number A is your hepatitis. Option B is some cholera. Option C is your typhoid. And option D is acute anterior polio myelithiasis. So acute anterior polio So these are the disease, and you are asked which of these disease are caused by viruses, right? So viral pathogens means what are the viruses which are causing these disease. You need to mark those disease which are caused by viruses, right? So when I talk about hepatitis, so hepatitis B is a viral infection. It is caused by a virus. So hepatitis B is again a viral infection caused by a virus. For hepatitis B, you need to get vaccinated, right? So hepatitis B is a viral infection. So option number A is correct. Cholera is caused by bacteria. Cholera and typhoid both are caused by bacteria. These are bacterial infections. As we know that for typhoid, it is Salmonella typhi is the name of the bacteria causing typhoid, right? So cholera and typhoid are both bacterial infection. When I talk about acute anterior poliomyelitis, right? Just forget the name, focus on the word polio. And we clearly know that polio is a viral infection. Polio is caused by a virus. Again, we need to take the vaccine of the polio, right? So majority of the cases where you need to take the vaccines for a particular disease, that disease are the viral infection. So hepatitis B and polio are the two diseases which are caused by the viral infection, right? So for this question, you can go with hepatitis B and acute anterior poliomyelitis, right? Next is, I need to check on the data for this question, right? Some data is missing for this question. As per now, whatever data is available with me or the kind of question is available with me, I am finding hepatitis and polio to be the correct solution for this, right? But still, I need to check on this question whether any additional data or any additional information is given to me or not, right? Now, moving on to the next question of environment. So the next question of environment was a matchmaking question where you have column 1, you need to match column 1 with column 2. You need to match column 1 with column 2. So column 1 starts with your reverse osmosis. Column 1 starts with reverse osmosis. Reverse osmosis, then you have trickling filter. Then you have coagulation. And last you have adsorption. Right. Column B starts with ponding. Then you have Freundlich isotherm. Then you have concentration polarization. And last one is your charge neutralization. So these are the two columns in which you need to match the correct options as listed, right? So as you can see here, for reverse osmosis, what is reverse osmosis? In the previous year, in the last year GATE examination also, we have find one question from this topic, from reverse osmosis. So reverse osmosis is a technique to remove salts from the water. For reverse osmosis, we use the semi-permeable membrane. So if I talk about reverse osmosis, RO, right? So this is a kind of arrangement we have for RO. We have this semi-permeable membrane like this. We have this semi-permeable membrane, and the water which is present in the first chamber, it is pressurized. It is pressurized, right? It is pressurized from one chamber, and due to this pressure, this water passes through this semi-permeable membrane. This water passes through this semi-permeable membrane, but the only thing is, the holes which are there in the semi-permeable membrane does not allow the passage of salts, does not allow the passage of salts through them, right? So on the other compartment of this reverse osmosis, on the other side of the reverse osmosis here, on the other side of the reverse osmosis, this water is free from salt, water free from salt. This water is free from salt, right? So reverse osmosis is a technique in which you use a semi-permeable membrane and you add a pressurized water in one chamber so that this water passes through the semi-permeable membrane, and this semi-permeable membrane does not allow the backflow of this clean water. Okay, this semi-permeable membrane allows the flow of water only in one direction, due to which this charge accumulation happens, and this charge accumulation is known as concentration polarization, right? So this reverse osmosis is related with concentration polarization. Concentration polarization is the accumulation of charged ions on a particular specific volume or a space, right? So over any space, if charge gets accumulated, it is termed as concentration polarization. Now next is, if I talk about trickling filter, so this is the thing that we have already discussed in the class. If I talk about trickling filter, so trickling filter is a biological treatment unit. Trickling filter is a biological treatment unit, right? So trickling filter is a biological treatment unit. If I talk about a trickling filter like this, right? If I talk about a trickling filter like this, so this is my filter medium. For a trickling filter, this is my filter medium. And if the voids of the filter medium gets choked, if the voids of the filter medium gets choked, right? If the voids of the filter medium gets choked, it does not allow the flow of fluid. It does not allow the flow of fluid. It does not allow the flow of fluid through its interconnecting voids. It will not allow the flow of fluid, due to which this water gets accumulated over the filter medium. This water gets accumulated over the filter medium. This wastewater which gets accumulated, this wastewater which gets accumulated over the filter medium is termed as the ponding problem. This is termed as the ponding problem. This is termed as the ponding problem, and this ponding problem we see for trickling filters. This ponding problem we see for trickling filters. This ponding problem we see for trickling filter. And why it is happening? Because the choking of voids is there, due to which the wastewater is unable to pass through the filter medium, right? So this kind of ponding problem is observed for the trickling filter. So in this question, for trickling filter, you are related with the ponding problem. For trickling filter, the problem is the ponding problem. Next is the coagulation. Now my dear students, what we mean by coagulation? Whenever in our water or wastewater, fine suspended solids are present, which take a lot of time to settle, we add coagulants from our side in order to just precipitate out these fine suspended particles. While discussing coagulation, I have told you one thing. When I talk about coagulation, right? When I talk about coagulation and these fine suspended solids, over these fine suspended solids, negative protective charge is present. Negative protective charge is present like this. In coagulation, we do fast mixing. We do fast mixing in order to provide sufficient amount of energy so that the coagulant can neutralize coagulant can neutralize this negative protective charge which is present around the surface of the fine suspended particles. So coagulation is related with the charge neutralization which is present over the surface of the fine suspended particles, right? So for this question, coagulation is related with the charge neutralization. Coagulation is related with the charge neutralization. And last of all, absorption is related with the Friedland isotherms, right? So these are the correct option. If you like to match it, you can have a clear view. Reverse osmosis is with concentration polarization, trickling filter is with ponding, coagulation is with charge neutralization, and adsorption is related with the isotherms, right? So these are the correct option that are there for this question. Accordingly, you can have a match for your question, right? So these are the questions. As we are getting questions, we are constantly discussing. If you people have the questions, just post it in the comment box and post it in our Telegram group, right? Join our Telegram group. You can post their doubts or even the questions that are there which were asked in the examination. We are constantly discussing for forenoon and the afternoon session, and we will continue with the questions. So my next faculty will continue here. He will join you right straight away.
Hello everyone, welcome back again. So as I'm having here few more questions of engineering mathematics and general aptitude. So let's start the very first question of engineering mathematics. This was an MSQ. This is a question from linear algebra, and we already approached the same pattern in our classroom because this is a concept based questions and this is an property directly from the properties of eigenvalues and eigenvector. So let's read the question, then we will approach it. The question is given the matrix A. We are having a matrix A which is a 3 cross 3 matrix. Even here it does not make any difference whatever the matrix is given to us. Okay, then it is asking about which of the given statements is or are correct. So we are having first statement, eigenvalue of A inverse, matrix A inverse and A are same. Second statement, eigenvalue of A transpose and A are same. Third one is eigenvector of A inverse and A are same. And last one is eigenvector of A transpose and A are same. So we can easily approach here. So as it is, we are having a matrix A first of all. So we know very well now ki if the eigenvalue we will find out. Suppose I am writing here ki if for matrix A eigenvalue is lambda, then for matrix A inverse the eigenvalue will be lambda inverse, as we know very well. So we are sure for this one that the eigenvalue, okay, it is asking about, wait a minute, so this one will also lambda. We can write down like this, just hold a second. We can write down, okay, let's read the one by one statement and then we can conclude it. So just read first one, eigenvalue of matrix A inverse and A are same. Yeah, surely, because it does not make any difference. Eigenvalue will be same always, as we know very well. When we talk about the eigenvalue of A transpose and A are same, yes, it will be same surely. If we are having a vector matrix as an A and we are having a matrix as an A transpose, for both the eigenvalues will be same. Now it is asking about eigenvector. So eigenvector of A inverse and A are same. Yeah, because eigenvector, if I am writing Ax is equals to lambda x, the eigenvalue will be lambda, but the eigenvector will be x same. So for each means if we are having a matrix A inverse, then also the eigenvector will be x. If we are having a matrix A square, then also the eigenvector will be x. So eigenvector will be same surely. Okay, no, it is not written as same. The statement is eigenvalue of A inverse is reciprocal. Okay, reciprocal of eigenvalue of A. Yeah, then it will be surely right. Let me tell you about this one. As we know very well, if we are having a matrix A For this matrix, eigenvalue is lambda. If I will find out the eigenvalue for A inverse, it will be lambda inverse. If I will find out the eigenvalue for A square, it will be lambda square, and so on. It will be going on. So we know very well, if the A matrix is having eigenvalue as lambda, then A inverse will having lambda inverse. So this is nothing but the reciprocal of the eigenvalue of matrix A. Yeah, surely. So this statement is 100% true. This statement is also true, as I proved here. Eigenvalue of A transpose and A are always same. The next eigenvector is always same. Okay, we are having, if the matrix is A inverse, then also the eigenvector will be same. So the eigenvector of A inverse and matrix A are same. But if we are having the eigenvector of A transpose and A, okay, these two things will be different. For the A transpose, eigenvector will be changed. It will not remain same. So that's why this statement will not be true. These three statements are absolutely right. Okay, eigenvalues of A inverse is reciprocal. Eigenvalues of A transpose and A will be same. Eigenvector will be same for A inverse. Even it can be for the adjoint, but it cannot be for the A transpose. Okay, so it will not be same for the A transpose. So these three options are correct and one is wrong here. So if this is an MSQ, so these three options are correct. Okay, so you can check according to the options, but these three statements are surely right. Okay guys, I'm having one more question of engineering mathematics. Let's approach to that. That question is of integration. So that is a MCQ. Solve the given integral. Solve the given integral, integration minus 1 to 1 1 by x square dx. Okay, so guys, had you approached this one? If yes, then just tell me the result. What was your result? And we are having options as 2, second one is minus 2, third one is 0, and last one is integral does not exist or not convergent. Integral does not convergence. Okay, so as we can solve this one, so whenever, as I give you one special keynote in my classroom also guys, whenever we are having a question in the limit of minus a to a form, so we have to identify first of all whether the function is even function or an odd function. We will not do it directly because now sometime, as right now here also we are having, when in the option we are having not exist, so especially don't do directly. Okay, maybe your answer will be wrong. So let's approach with the pattern, so it will be clear, or it will be give you a clear and right answer. So we can see here minus 1 to 1, as I can see my function is surely an even function. Why it is even function? Because when I will approach at the place of x here, it will give me as it is the function of x again. So f minus x is equals to fx here. That's why this is an even function, that we know very well. So when it is an even function, we know for the even function the result will be twice 0 to a fx dx. And if the function is odd, the result will be 0. So we will go with this term. So we can write down the integration as twice 0 to 1 by x square dx. As if I will go with the integration of 1 by x square, it will be minus 1 by x, and limits we are having as 0 to 1. So we can take negative as outside. We are having 1 by x. Now we can put the limit as 0 to 1. When we will put the limit, we can see clearly it will be 1 minus 1 upon 0. 1 upon 0 will become infinity, and when infinity is there, infinity into something will be infinity surely. So it will give me the result as infinity. So the limit for this one will not exist surely. So the function will not be convergent. So we can approach it. The result or the integration of this given function will not be convergent. It will not a finite value. It will not a bounded function. So we can solve it surely. Yeah. So it is not minus 2. It is not minus 2. Beta, you have to solve like this one. It will not minus 2. Who's that? Moyank. Okay. So please check again. So this will be not convergent, because when we will solve it, it will be 1 minus 1 by 0. 1 by 0 is infinity, and when we will solve, it will be an infinity function. So that's why the function is not bounded, or it is not convergent. Okay. Now I'm having few questions of general aptitude also. Now let's approach to the questions of general aptitude. The very first question from the verbal segment, and this is a statement based question. I have not decided yet. I have not decided yet what I will do. What I will do this evening. This evening I blank space is there. Visit a friend. I visit a friend. Okay, so we are having options also for this one. Might, MIGHT, might. Second option is MITE, might. Third one is did not, and the next one is will. So we can approach it. So might is correct. Sure, very good. Shekhar, shabash. So we can see the result as beta. This is have not is there na. So this is the past tense. So past will be not possible here, and this is denoting the future. So future is also not possible here. So these two things cancel out. Now we are having either might, MIGST, might, which is denoting the possibility, or MITE, might. This is the meaning of the meaning of this word is insect, है ना? Insect. Okay, कीड़े, जानवर, जो छोटे से जानवर होते हैं, just like small insects. That is the might. So this is also not possible. So the possibility is denoting by only and only MIGHT, might. So that's why the right answer will be MIGHT, might. So this is the final answer, and we can approach it very easily. Yeah, clear guys? Yes guys, clear? Okay, now let's approach to the next question. So this was the first one. Second is also a question of verbal. So this is of antonym type of question. Eject and insert we are having. Next is advance, and here the blank space. The options we are having as an advent. Second option is progress. Third option is loan, LOAN, loan. And the last one is retreat. Okay. So as eject meaning okay, to take again, insert is to insert simply. So these two things are opposite or antonym of each other. Eject and insert having a relation of opposite or antonym. So we need to identify which one is having. Very good, Mayank and Shekhar, shabash. So loan is not possible as the word is not matching at all. Okay, I will come to this one. Progress is also not possible. Advance and progress is also not possible. When we talk about the word advent is actually the starting or beginning of something. So this is also not possible. When we talk about the retreat is withdraw something. Retreat is withdraw. When we talk about the advance is the advance, and when we talk about the retreat, it is act of moving back or withdrawing something. So this will be the best suitable word here. So this will be my final answer. The retreat will be my final answer. I can approach here. Okay, shabash. Now let's come to the next question. This is a very good question of hexagon. Okay, so question number 3. Find the area of shaded region. Okay, when it is a regular hexagon. When a regular hexagon is given to us. Okay, regular hexagon with the side 5 cm is given to us. So let me draw the hexagon for you, then we will approach the result. Okay, it looks like here. It is okay. Yeah, we are having figure like this, and in this one the side is 5 centimeter given to us, and it is asking about the area. It is asking about the area. One circle is also there, and they are asking about the area of this shaded region. Okay, so we need to find out the area of this one. Might be we are having options in this one, but right now I don't have, so I will go with the direct solution. So let's approach it. So whenever we are having a regular hexagon, first of all, you guys might know about this one. Regular hexagon means each and every side is equal. So when it is 5 centimeter, it will be also 5, it will be 5, it will be 5, and it will be also 5. Let's reconstruct this one, something here, and then we will approach to the solution, guys. Yeah, very good. Who's that? Shekhar. Shabash. So let's approach it. So if this is my yeah, we are having a hexagon, something, wait a minute. Okay, something like this. So here the side is 5 centimeter. I'm drawing here the diagonals. Okay, this one also we can draw. So I'm drawing here the diagonals in this regular hexagon. Okay, first thing, and it is asking about a circle. So I'm supposing a circle is here, this circle is here, this circle is here. Okay, and if we talk about the center of the circle, this point will be the center of the circle, beta. First of all, as this side is 5 centimeter and this is my center of circle, it means this is nothing but the radius of the circle, 5 centimeter. Now if this is the radius, then this must be the radius. This will be 5, this will be 5, surely this will be 5. Okay, each and every side will be 5 also. I'm telling you why. Because now whenever a regular hexagon is there, okay, regular hexagon always makes 6 equilateral triangle in it. When we will draw the diagonals here, so it will make 6 equilateral triangles with the same size. Surely we know. So this is 5, 5. So each and every, we are having here the equilateral triangle, and these 1, 2, 3, 4, 5, 6 equilateral triangles we are having here, and the side is 5 centimeter. So if I talk about here, this is the 5 centimeter, this is the 5 centimeter right now. Now let's talk about this angle. If we can find out this angle, we can easily approach it. Okay, how to find out the angle of a regular hexagon? As we know very well that sum of all interior angles of a regular hexagon we can find out by 2n minus 4 into 90 degree by n. This is the sum of all angles of a regular hexagon, sum of all interior angles, sum of all interior angles of a regular hexagon. If I will put here the value n will be 6, then it will be 720 by 6, so it will be 120 degrees. So each angle will be 120 degree. We can approach it. So this is the formula and we can find out. So if I will go with the 120 degree, I can write down this is the angle 120 degree. So I'm having the angle as 120 degree. One very important thing you have to understand. If I talk about the complete circle, beta, complete circle is having 360 degree angle. And I need to find out the area of that circle which is having 120 degree angle. So I can write down one statement here. The required area, okay, let it be the required area is consisting this thing, including the extra portion which is in the circle also. So this area, this zigzag portion will be my requirement. The complete, this will be my required area. So how we can approach? We can write down here the required area is actually nothing but the required area is actually nothing but the 120 degree of the complete circle's area. So I can write down this is nothing but the 120 degree of complete circle's area. So as we know that why I'm writing 120 degree, either you can write down 120 degree as an 1/3 also, because when the complete angle is 360 degree, then 120 degree will be the 120 degree will be the 1/3 portion of this one. So we can write down like this also. It is nothing but the 1/3 of complete circle's area. Okay, full circle area. So we can write down like this also, 1/3 of the complete circle area. So as we know the area of circle is pi r square, and I need to approach here 1/3, so 1/3. What is r? R we already find out, which is 5 centimeter square, 5 centimeter. So we need to go with the square. So it will be 5 square. When we will solve here, it will be 25 pi by 3 beta. So this will be the final answer. It will be 25 pi by 3. Yeah. Either if you want, then you can go with the one. You can go with this manner also, Sushant. So it will also give you the result same as 120 by 360 degree. Okay. So we can solve the question like this one. This is a very good question of geometry. Now let's approach to the next question. Next question I'm having, let me find out. I'm having, this is again a question of area. So this is here also we are having some shaded region. They are asking about find the area of the shaded region. Find the area of shaded region. Okay, the figure looks like when we are having a square of 4 centimeter. Okay, when we are having a square of 4 centimeter side. Okay, so let me draw a square here for you. So for this one we are having side as in 4 centimeter, and okay, it is given to me like this, and this is a semicircle. Okay, and we need to find out the area here. This one, this one, this one, and this one, and the side of square is 4 centimeter, and this is also 4 centimeter. Okay, if this is 4, we can go with the 2 centimeter half. If I will draw here something, so it will be 2, and this will be also 2, and 2 and 2 we can convert. Now how to approach it, beta? So for this also, this is an for this also I don't have options. Maybe this is an NAT, because in this one we are having an integer value. So maybe this is an NAT. You guys can confirm whether it was an NAT or MCQ. So now easily we can find out here one simple thing. First of all, as I can see this portion, beta, I'm talking about this one also. This one only, this portion. Let me use the different pen so that I can give you some clarity. Look at here. When I talk about this green portion, okay, this is nothing but the quarter circle. So we can write down the 1/4 of the circle. This is nothing 1/4 circle. This one is also a 1/4 part of a circle, quarter portion of a circle. So these two are nothing but the quarter portion of circle only. So if I need to find out the area of this one, I can go with the 1/4 of the area of circle. So these two areas we can write down for these two things. I can write down the area of 2, or let it be area of 1/4 of circle. It will be 1/4 into pi r square. As the r, we can see this is the radius. The radius is 2 centimeter only, because this is the half. So I can write down the radius here also. This is the 2 centimeter. Here also this is the 2 centimeter. So we can go with the 1/4 into pi, and r square is 2 square. So 4 and 4 will be gone. We can write down for the one quarter, means one portion of the 1th quarter, or this quarter is 2 pi. We are having pi. For this one also we will have pi. So we can add pi plus pi. It will be 2 pi. So I am writing here area of 2 1/4 portions. So this will be 2 pi. So this will be 2 pi for me. Yeah, surely. When it is pi, then it will be 2 pi. First thing, I need to find out these two things also. For finding these two things, we can use two things here. First, we can see this green portion is nothing but a rectangle. And from the rectangle, we can just subtract the area of this semicircle. Okay, from the area of rectangle, we can just subtract the area of this semicircle. Then we will get these two shaded regions, area of these two shaded regions. So we can solve it. So let me write down from here the area of rectangle. For rectangle, the area will be L into B. So as the 4 centimeter is the length, and here we are having 2, so it will be 4 into 2 or 2 into 4, 8. When we talk about the area of the semicircle, so we can write down the area of the semicircle which is making in upper side. So area of semicircle is 1 by 2 of pi r square, as the r radius is 2 centimeter only. We are having the radius is 2 centimeter. So we can approach from here 1 by 2 pi, and r is 4. So r square will be 4. So it will be 2 pi. So the total area, that the required area, not the total area, the required area will be, I'm writing here the required area. So the required area will be from here, the area of rectangle minus the area of semicircle. So it will be 8 minus 2 pi first thing. Plus we need to find out the area of these two things also. These are also the shaded regions. So we need to find out the area for this one also. So which is 2 pi. So we can go with the 2 pi. 2 pi and 2 pi will be gone. Hence my result will be 8 centimeter square. So this will be the final answer. So guys, tell me, had you approached this one? Had you approached this question also? So this was the result. Yes, clear? So 1, 2, 3, 4 questions we approached. I'm having one more question from aptitude, which is the question of log. Okay. Yes. All right. So now let's go with one more question of aptitude. It is written to us, if A is equals to 30 factorial, B is equals to 50 factorial, and C is equals to 100 factorial. Okay. Then arrange what we need to arrange: log C to the base A. Okay. Log A to the base C, log B to the base A, and log A to the base B. We are having options also. So I am writing this as an MCQ. So I am writing options also for you. First option is log A to the base C is less than 2 log B. Log A to the base B is less than 2 log C to the base A, and it is less than 2 log B to the base A. Second option, log A to the base C is less than 2 log A to the base B, it is less than 2 log B to the base A, and it is less than 2 log C to the base A. Okay. Third one also, log A to the base B less than 2 log A to the base C. Okay. And it is less than 2 log B to the base A, and it is less than 2 log C to the base A. And one last option we are having as log A to the base C less than 2 log B to the base A less than 2 log A to the base B, and it is less than 2 log C to the base B. Okay. Now let's approach it. As it is given to us, so we are approaching this way only. So first thing we are having as in log C to the base A. C is 100 factorial. So if I will write down here, the 100 factorial base will be 30 factorial. So 100 factorial and 30 factorial. Okay. So as first of all, we know very well, guys, if we are having a concept like log A to the base B and it is equals to X, we can always let it be B and A. B or A. Okay, we can always write down from here that the B is nothing but A to the power X. We know this concept in the log. So from this concept, suppose I'm taking this equals to X. Let it okay, assume the quantity equals to X. When I will approach it from here, I can write down that here the log 100 factorial is nothing but, or if I want to go directly, I can write down directly with the help of this concept also, beta, ki the 100 factorial is 100 factorial is nothing but X to the power 30 factorial. I'm having right now this concept. I want to make it more simple, so I want to find out the value of X. So my X will be 100 factorial to the power 1 by 30 factorial. First thing we are having, we will check the values 1 by 1. So first thing we are having here. Now let's approach for this log a to the base c. Log a to the base c, and as the value of a is 30, so it will be 30 factorial. This will be the opposite of this one, so we can easily find out. But let me complete 100 factorial, and let us assume this is equals to y. When we will solve from here, 30 factorial is equals to y to the power 100 factorial. So you can write down y is nothing but 30 factorial to the power 1 by 100 factorial. This second thing we are having, okay, y is nothing but 30 factorial to the power 1 by 100 factorial. Now okay, if you want to compare from x and y, we can easily see beta that x is greater than to y. If you want to compare between these two things only, we can easily see that x is greater than to y, because x is the 100 factorial to the power 1 by 30 factorial. Okay, and this is the bigger number, and this will be 30 factorial to the power 1 by 100 factorial. This is a smaller number because we are having here the small number to the power small, okay, and bigger number to the power bigger. So it will be surely a bigger number. So when we compare x and y, it will be x is greater than to y. Let's go for the next thing also. Next was b to the base a. So log b to the base a, okay, the value of b was 50, I think. Yeah, 50, and a is 30. So we can write down log 50 factorial, 30 factorial, that let us assume that is equals to p. Let us assume that is equals to p. So when I will write down from here, I can go with the 50 factorial is nothing but p to the power 30 factorial. So that we can write down p is 50 factorial to the power 1 by 30 factorial. Okay. Let us find out the last value also, then we can compare. The last one is log a to the base b. So we can approach similarly log 30 factorial, 50 factorial, and let us assume it is equals to q. So we are assuming it is equals to q. So from here I can get the value of q. From here I can get the value of q, which is nothing but 30 factorial to the power 1 by 50 factorial. So from here also we can compare the bigger number with the bigger power, smaller number with the smaller power. We can compare p is greater than to q. Now let's compare with throughout x, y, and p and q. So when we will go with the comparison, let me write down which one is the bigger number. Okay, we are having here x, y, p, and q. Okay, we are having here x, y, p, and q. So I am writing the value of x one by one. X is the 100 factorial to the power 1 by 30 factorial. Okay, y was 30 factorial to the power 1 by 100 factorial. Yeah, this was my y. P is 50 factorial to the power 1 by 30 factorial, and q is opposite of this one, 30 factorial to the power 1 by 50 factorial. We are having every values here now. Now we can easily compare beta ki among these values the bigger number is x only surely. Okay, and among these value the smaller number will be y. So we can start. If we want to start, look at the options. Look at the options. We are having options, and in options we are having the smaller number first and then the larger number. So we can start, and the last will be x from here surely. Okay, because this is the largest number. Now which one is the smaller number? We can see the smaller number is y, because 30 factorial to the power 1 by 100 will be a smaller number as compared to the 30 factorial to the power 1 by 50. So y will be the smaller number, x will be the larger number. Okay, now the next will be these two are done. Next will be between p and q. So we know that between p and q the next will be q, and then we will go for the p. So it will be q, then it will be p, and then it will be x. So this will be my sequence. Okay, if we want to check in the option, then y, we just approached y as in log a to the base c. So it must be my first option, log a to the base c, log a to the base c. Okay, this will be gone. Log a to the base c we are having here, but it is not here. So this one also gone. So log a to the base c. Then we approach to the q. Q we consider as in here the q. So q we consider as in log a to the base b. So log a to the base b. Yeah, these two options are possible. These c and d will be gone. So these two are correct. When we check about the third one, log B, okay, third one, we can directly approach from here only na. This is the x. We already approached x as in log C to the base A. So this will be surely my answer. So the option B. So the bigger number will be, sorry, the smaller number will be log A to the base C, then log A to the base B, then log B to the base A, then log C to the base A. This will be the sequence. So this will be the final answer. So in this way we can approach it very easily, guys. I hope it is clear to everyone. Yes. Okay, so till now I'm having these questions only. Okay, the technical portion will be going on, so you can just continue here with the technical also. If I will find more questions, I will come again live. Okay guys, stay tuned to our YouTube channel. Thank you.
So, hello guys. So I think you are enjoying the session, right? So we have solved so many subject questions, okay? One by one faculty will come and they will solve their respective subject questions, right? I'm ready with one more question actually. This is from fluid mechanics. And see, generally this type of questions they will not ask, but this year they have asked this question. So generally the possibility of such type of questions is what very less, specifically in the civil engineering. Generally in the mechanical engineering we used to have such questions, right? So we'll see what is that question. Just a minute. Yes. Right. So it was a question of a turbine actually. I would say it's the impact of jet. So this is what they have given as a nozzle, okay, from which a stream of jet is coming. Okay, jet is coming and it strikes the wheel which is having the plates like this, right? So obviously this stream will have a certain velocity v, and they have mentioned this wheel is rotating with some velocity u, okay? So both the values were given and they are asking the efficiency. So velocity v is given as 20 meter per second and this u value is given as 15 meter per second, right? So this was the question and they were asking what is the efficiency in this case. So it was a very basic simple question, because see, directly you can apply engineering mechanics concept here in this case, right? So I hope this point is clear. Now we will see derive this formula here, so that see you will be able to understand what actually concept involved in this particular question, right? I will not directly write the formula, I will just derive the formula here itself, right? So see, a stream of jet is coming and it will strike the plates of the wheel. So different plates were there on this wheel and obviously it will going to rotate, right? Now if I use basic mechanics question, that is impulse momentum equation, right? So from impulse momentum equation, try to understand this point. Impulse momentum equation, I will get the value of the force, okay? From this impulse momentum equation I will get the value of the force, okay? So obviously it will be equals to what? Change in the momentum. See, what is the mass flow rate here, okay? Here the mass flow rate will come, here the final velocity and initial velocity will come. Now you should understand the initial velocity with which it strikes. See, it is rotating with u, it is coming with v, so relative velocity we need to take care, okay? V minus u we need to take minus 0, because finally the velocity will be 0. After striking, the jet velocity will become 0, so that's why 0 here. What is the mass flow rate? Mass flow rate of the jet. Okay, so instead of writing mass flow rate, you can write, actually the mass flow rate you can write like this: density into area of a jet into velocity v. So this is what we are having, the mass flow rate of the jet. So this is the force. Now in order to calculate the work done, okay, in order to calculate the work done, what we will do? Work done per second. Simply you will multiply this force with the rotational velocity u. Okay, you will get the work done per second. Now in order to calculate the efficiency, see what we'll do here. In order to calculate the efficiency part, it is equals to work done per second divided by the kinetic energy. Kinetic energy, which is what? Kinetic energy of the jet. Okay, the kinetic energy of a jet with which it is striking the plates. That kinetic energy we need to take care, right? So this kinetic energy. So work done we have already calculated. See, work done, F into U we need to just multiply. Okay, now see, mass flow rate multiplied by V minus U into U. So it is the work done. kinetic energy will be what? Half mv square, m dot v square, right? So this is the kinetic energy. Now just simplify this equation. You will have this thing, okay, 2 into v minus u into u divided by v square. So this is the formula you will get, right? So they can also ask the maximum efficiency. Okay, just differentiate this relation and you will get the value of u by v. For that u by v value, efficiency will be what? Maximum, right? So but they just ask the value of efficiency. We will put the values of v and u because it is given in the question itself, right? Velocity v is 20 meter per second, u is what? 15 meter per second. Okay, I hope this point is clear, right? Just we need to put the values here. So see, even if you know the basic concepts of engineering mechanics, you can easily calculate the efficiency also, because efficiency is nothing but the work done per second divided by the kinetic energy with which the jet is striking the plates. Okay, now so we have put all those values. Okay, now we'll put the values here in this case. So 2 into 20, capital V is the velocity of the jet. Okay, so okay, so 20 minus 15, u value is what given as 15, into 15 it is there, okay, divided by v square, that is 20 square, right? I hope this point is clear, everyone. Now please calculate the value of the efficiency and tell me the answer. What answer you are getting? Tell me, everyone, fast. What will be the final answer you will get after putting all those values? Tell me fast. Simple. See, for such kind of numerical, you don't even require any calculator. You can basically directly calculate all those things, right? See, it is what 2 into, it will be what, 5, 15, and here it is 20 square, right? So it will be 10 here, then it will be 2, 3, and it will be 4. So 3 by 8 it will be there. Finally 3 by 8 will be there, and if you solve, it will come out to be 37.5%. So that will be the answer for the efficiency in this case, right, everyone? So see, even if you don't remember the formula, you can easily derive the formula also, if your basic concepts of engineering mechanics is clear. So that's why we always focus on the basic concepts. If your basic concepts of the mechanics is clear, you can easily solve the numerical of fluid mechanics, strength of material, right, and this hydraulic machinery, steel, RCC structure. See, the basic foundation of all engineering is what? The engineering mechanics only. If your fundamentals are clear, then you can easily solve the application related formulas or the concepts. So I hope this question of this fluid mechanics is clear to everybody. Now Ankit sir will come and they will discuss a few questions, right? Okay, thank you, Sai.
Yeah, hello everyone. I hope your exam is good, right? So it was easy or hard? The exam was easy or what? It is moderate, easy. So okay, just tell me, have you solved the questions of steel? Have you solved the questions from soil mechanics, right? So I think if we talk about the exam, it was easy paper, yes or no? So if we talk about geotechnical engineering, irrigation, hydrology, from the basic concept they have asked, right? So most expected questions they have already asked. But if we talk about the environmental engineering or transportation engineering, it was just away from the normal pattern, right? Okay, so I am here with some questions from the open channel flow, right? So we can discuss some of the questions of open channel flow. So tell me if you got this particular question or not. So I have one question, that when a supercritical flow, when a supercritical flow enters mild channel, flow profile will be, right, and options are given to you: M1 profile, M2 profile, M3 profile, and D, M1 and M2 profile. Right? Tell me if you have solved this particular question or not. Have you solved this particular question from open channel flow? Right? So in our course also we have discussed, or in YouTube series also we have discussed this particular concept, right? How you can find out what will be the particular flow profile. Now, if we talk about the subcritical flow enters a mild channel, right? What is your subcritical flow? Can I say for subcritical flow? Can I say for subcritical flow? We know that for subcritical flow, your critical depth, it will be greater than what? Your normal depth, right? Or can I say that this is the condition, this is particularly the condition also for a steep slope? This is the condition for your steep slope, right? So mainly the examiner is asking you a question that when a particular slope which is steep and after that it is followed by one particular channel which is mild. So this is your steep and this is mild. This is mild, right? Now we know that for a steep channel, let's suppose this is my critical depth. This is your critical depth, right? For the analysis of flow, we assume that critical depth is constant, right? Or at the same height. It does not depend upon the slope of the channel. It does not depend upon the slope of the channel, right? So this is your, let's say this is your YC value. This is your critical depth, right? Now if it is a steep slope, so my normal depth, it will be below the critical depth. So let's suppose this is your normal depth, right? So this is my normal depth. Now when there will be a mild channel, we know that for mild, your Y critical or your Y normal, it will be greater than Y critical. Your Y normal, it will be what? It will be greater than Y critical. If slope is decreasing, definitely depth will increase, right? And normal depth, when it will become greater than critical depth, you will say it is a mild slope, right? It means now the normal depth will be somewhere here, right? So now this is your normal depth here. This is your normal depth here. Now, for this particular depth to reach this particular value, as we assume that the flow is taking place at normal depth, so there will be a particular jump, there will be formation of jump, and it will goes to this particular part, right? Now if we talk about this particular profile, so this will be your what? This will be your M3 profile, right? There can be another chance that if let's suppose the flow occurs like this and it reaches to this particular point, so here you will find out that this is your S1 profile, right? But if we see the options, all the options are given for this mild, all the options are given as for the mild slope, right? So out of these particular options, which particular profile we will find out when there is a steep slope and after that it is followed by this particular mild slope, right? So what will be our answer? Our answer will be option number C. Our correct answer will be what? M3 profile. Clear this thing, right? So this is one question from your open channel flow. There was another question asked from the hydraulic jump, right? So the concept of hydraulic jump, it is used. So what was the question? If we talk about the question, so the question says a hydraulic jump occurs. A hydraulic jump occurs in a 1 meter wide horizontal frictionless frictionless rectangular channel. Rectangular channel. Right? With a pre-jump depth. Pre-jump depth. That is, we generally mark it with y1. It means this is the jump, this is the depth before jump, right? And this y1 value, it is given as what? It is given as 0.2. 0.2 meter. Also, post jump depth is also given to you. Post jump depth. That is our y2 value. And it is given as again 1 meter. Again 1 meter. Right? Also, it was asked to take the g value, that is acceleration due to gravity, as 10 meter per second square, right? And it is asked that, we know that these are the y1 and y2, they are the conjugate depths, right? Or we also call them the sequent depth. Yes or no? Right? 70 answer. 70 for which question? Star. For which question you got the 70 answer? For this one? Yes? Okay, we'll see, right? So, in last question we got this M3 profile. For this you got 70. Okay, we'll just see. Hydraulic pump. Okay, for hydraulic pump. Okay, right? This is y1, y2 values are given. We know that these are the sequent depth or conjugate depth. And sequent depth or conjugate depth are those depths at which specific force will be same, right? And it was also given in the question that for y1 and y2, although even if it was not given, we know this particular thing, right? For y1 and y2, specific force is same. We know this thing. Specific force is same. Now it is asked that what will be the value of this specific force? What is the value of specific force? Specific force, right? And this particular value will be in what? It will be in meter cube. This particular value, it was asked, right? Now, how we can approach this particular question? We know that specific force from the momentum equation we can calculate, right? And we have derived one particular formula also, that specific force, if we talk about the solution, we know that specific force in case of rectangular channel, or this particular formula, it will be valid for all the channels. We will develop it for rectangular channel also. Specific force is what? A into Z bar plus Q square upon A into G, right? Where A is what? This is your wetted area. Z bar is what? Z bar is the CG of this particular cross-sectional flow area. Yes or no? Right? Q, we know that this is the discharge value. Now, if there is a rectangular channel, right? Let's suppose this is our rectangular channel. Right? Now, this particular y1 and y2 we know. What will be Z bar value? Let's suppose this is the depth. This is the depth. Either we can use y1, we can use y2. Right? Now it is better if I use the value of this particular y2. As this y2 is what? This y2 is 1 meter. Right? So y2 is 1 meter. So I'll use for the calculation of this as y2. So y2 is equal to 1 meter. Let's suppose. So what will be my z bar value from the top surface or from the free surface, whatever is the CG of this particular section, that is our z bar value, right? For this it will be what? It will be y2 by 2, or if I just for the particular time, if I assume this depth to be y, it will be what? Y by 2, right? So I can write this particular formula as what? Specific force will be equal to A into y by 2 plus q square upon A into g. Yes or no? Now try to understand, as these are the conditions given to us. It is horizontal, frictionless, rectangular channel, right? So when we derive the relation between sequent depth, that is y2 upon y1 relation, right? So in that particular case, we also find this particular value as q square upon g. If you remember, we have given this as a standard formula also, q square upon g. It is equal to half y1 y2 y1 plus y2, yes or no, right? So from here I can find out this q square upon g value, that is half. What is y1 value? So y1 value, it is given to me as 0.2, y2 value is 1. So 0.2 and 1. So it is 0.2 into 1 into 0.2 plus 1, right? So it will be what? Half 0.2 into 1.2. This is nothing but equal to 0.12, right? This particular value is 0.12. Now try to see this particular value. Try to see only this particular value. Can I write this particular value as discharge q square upon A square into g into A? I have just multiplied numerator and denominator with A value, right? So it is q square into A upon A square into g. Now remember, this for rectangular channel, this A square will be what, or this A value will be what? A will be equal to B into y. So A square will be B square into y square. A square will be what? B square into y square. Now q square upon B square, q square upon B square, can I write it as small q square into A upon g into this particular value y square? Yes or no? So I have just written this particular formula into this particular form, so that this q square upon g value I have already calculated. I can put this particular value here, right? Now in this particular formula I can use y as y1, or even I can use y is equal to y2, right? From both the depth you will get the same answer, as the specific force value for both the depth, it is what? It is same. Clear? So let's say if I take y is equal to y2, if I take y is equal to what? y2, right? So try to focus in this particular formula. So what will be my specific force? My specific force A is what? A is, now I am taking the depth is equal to what? y2. I am considering depth as y2, that is 1 meter. So it will be what? 1 into 1. This will be my area, B into y. B is also 1, y is also 1, into y2 by 2. Depth is 1 by 2, plus this particular value q square upon g. Q square upon g we have just calculated, it is 0.12 into A upon y square. A is nothing but 1 into 1, only one value, upon 1 square, right? So this will be 1 by 2, 0.5 plus 0.12. So it will be what? 0.62, 0.62 meter cube, right? This will be your final answer. This will be the value of specific force. Just let me know if you got the same answer or not. Have you got the same answer? Yes or no? Right? So the correct answer will be what? 0.62. Clear? What will be the units? It will be A into Z bar. A is your meter square into Z bar is what? Again, meter value, right? Now, These are the two questions from your open channel flow. Now we have one question from geotechnical engineering also. We have one question from geotechnical engineering also, right? So what this question says, this question, it is related to compaction. There is one question from geotechnical engineering. So related to compaction curve, they have asked a question. They have asked the question. Now, there were 4 statements were given, right? Regarding the compaction curve, 4 statements are given, and you have to find out which of the following statement is incorrect. Remember, the question which was asked is which of the following option is incorrect, right? So question, so statements are given regarding the compaction curve. Statements are given regarding the compaction curve. The compaction curve. And what you have to select? Select which of the following statement are incorrect. Select which of the following statements are incorrect. Are incorrect, right? Remember, they have not asked for the correct options, they have asked for the incorrect options. This was MSQ type of question, so it may be possible that some student might have gone for the correct options also, right? So what were the options? Statement number 1. First statement, it was given that with increase in compactive effort, 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 OMC decreases. OMC decreases. Tell me if this statement is correct or not. This statement is correct or this statement is incorrect? Tell me. This statement is correct or incorrect? So I think everyone who has studied soil mechanics will be able to answer this particular question. Yes or no? Right? So with increase in compactive effort, OMC decreases. Definitely we know that if you remember the compaction curve, so here it is OMC, or here it is water content, right? Here it is gamma D value. Yes or no? Right? Now with compactive effort, we have seen that, let's suppose this is regarding the energy E1. Now if you have provided more energy, if you have provided the more energy, this particular curve, it will shift upward and left side, right? Yes or no? If you remember this particular concept. So here what we are assuming, E2 is greater than E1, right? Now this particular value, it is your gamma D max value. For this particular curve, this is your gamma D max value, and this is the particular, the moisture content at which you are getting the maximum dry density, that is your OMC. So this is your OMC number 1 and this is your OMC number 2. Yes or no? So when your compactive effort increases, it means compaction energy increases, so your OMC decreases. It means this particular statement is correct, but it was asked to find out the incorrect statement, right? It means this particular option we will not choose. Clear? Option B. Option B, it was given as with increase in compactive effort, with increase in compactive effort, in compactive effort, gamma D value, maximum dry density, gamma D max value increases. This value increases, right? Here we can see again in this particular curve, As the compactive effort increases, your gamma d value increases, right? Or gamma d max value, it get increased. So this was gamma d max 1. This was your gamma d max 1. This is your gamma d max 2. Clear this thing? So gamma d max 2, it is greater than gamma d max 1. When energy increases, your gamma d max value increases, right? It means this statement is also correct, but we have to find out the incorrect statement. This option you will not select. Third option was given as the peak of compaction curve. Peak of compaction curve gives the value of gamma d maximum, that is maximum dry density, and OMC. Tell me if it is correct or not. Yes, absolutely correct. We can see that at this particular point we are getting the peak of this particular curve. So at peak of this particular curve, whatever is the gamma d value, that is our gamma d max, and corresponding to that the water content, we are saying it as optimum moisture content. So this particular statement is also given correct, right? Now if we talk about last statement, so last statement it was given as zero air void line. Or it was given as compaction curve. Compaction curve coincides with zero air void line. Coincide with zero air void line. If you remember the curve, we have seen that the zero air void line, it will pass through this particular point. Yes or no? Right? So this is what your zero air void line. So we know that zero air void line does not coincide with this particular compaction curve, right? So this is your zero air void line. It means this particular statement is wrong. This particular statement is incorrect. So our correct answer will be what? Our correct answer will be option number D. Just let me know if this was the question, right? This was the particular question. Okay, thank you. Now, this is the particular question from your geotechnical engineering. Again, there was a question from geotechnical engineering for the calculation of critical height of excavation, right? So again there is a question from geotechnical engineering. So those students who have given this particular forenoon session, they would be having this particular idea that from this calculation of critical height of excavation, 2 or 3 questions are asked. Yes or no? Right? So your subject is what? Geotechnical engineering. We are seeing this in question. So what this question says, the question was given as, I am having the data that gamma bulk, it was given to you. It is 19 kilonewton per meter cube. Phi value, that is angle of internal friction of soil, it is given to you as 25 degree, right? Cohesion value, it is given to you as 15 kilopascal, and it was asked to calculate the HC value. It was asked to calculate the HC value, right? Yes or no? Now try to understand. In Janagar centers, classes are already running, right? Yeah, high electrical. In Janagar center, the classes are already running. You can just visit the center, right, to get the idea about the timings of the classes. Clear? Okay. Now, in this particular question, they have asked for this critical height. Also, if I remember, the question was like this, that there is a particular slope. There is a particular slope, right, whose inclination angle was given to you. Whose inclination angle was given to you, right? And this inclination angle was given as 35 degree. and this soil, it is placed over this particular, right? This was the particular soil, and you are making the excavation in this. You are making the excavation in this. Is this the question? This was the question, right? Now, if you are trying to excavate this particular, so they have asked for the depth. They have asked for the depth of excavation, right? So we are assuming this is the particular depth of excavation. This is the particular depth. We are excavating this particular soil. So let's suppose up to this particular point, we got that particular HC value. This is the critical height. This is your critical height. Clear? Now, this HC value, we know that this HC value will be what? This HC value will be your 4C upon gamma under root of K. 4C upon gamma under root of K. Gamma under root of K, right? What is this K? K is your active earth pressure coefficient, that is given as 1 minus sin phi upon 1 plus sin phi. It means 1 minus sin phi, that is 1 minus sin 25 degree upon 1 plus sin 25 degree. If you calculate this particular value, you are going to get it as 0.405. So this is your K value. All other values are directly given to you. So 4 into C, cohesion value is given to you as 15 upon gamma value, it is, gamma value is also given to you 19 into under root of this particular value 0.405. 0.405. Clear? So the answer which we are getting for this particular question is 4.957 meter. 4.957 meter, right? Now it depends that if they have asked this particular HC value or this particular vertical height, or this particular vertical height, right? So if vertical height is also asked, you can just take the component of this particular height, yes or no? You can just take the component of this particular height, right? But if they have asked for this particular depth, so it will be what? It will be same as the calculations which we are doing for this particular horizontal surface, right? When we are doing the excavation in this particular horizontal surface. Clear this thing? So this was your question from Geotech. There is another question from your irrigation, right? I am getting one more question for the students from the forenoon session for this irrigation, right? So in irrigation, they have asked one question. So from duty delta, that is the mainly hot topic which we recommend a student to read from the irrigation, right? Whenever any particular student, even if any student will ask you that what should I study from the irrigation, so at least you will say duty delta you have to study, right? So from duty delta they have asked you a question. Clear? Now the question was a canal is used to irrigate, to irrigate 100 hectares, used to irrigate 100 hectare of wheat, 100 hectares of wheat, right? And the total time between first watering and last watering, the total time between first watering and last watering was given to you, and last watering is given as 120 days, right? It means this is what? This is your base period, right? And the total depth of water which is required for this particular base period, it is also given, and depth required is what? Depth required is 35 centimeters. Depth required is 35 centimeters. Clear? Now, for this particular value, they have not asked the discharge value. They have given you the particular value of time of core period also and the depth which is required in that particular core period. We know that in core period, you have to apply the maximum water just after when we just show the crops. After that, we apply some extra water. That is what? That is your core water or maximum water which is provided, right? So it was given that the core period, it is of what? It is of 30 days. And during these 30 days, the water which is required, depth of water which is required is given as 12 centimeter, right? It was said that neglect the losses and find the design discharge. For what discharge you will design this particular canal, that particular value is asked, right? Now try to understand. We need to satisfy the irrigation requirement of crop both in this core period and also in the regular period. Yes or no? So how much discharge it will be required during core period and how much discharge it will be required in the normal days, that we can calculate. Out of that, whichever value will be maximum, if we provide or if we take that value as a discharge, as a design discharge, definitely the irrigation requirement of crop, it will be fulfilled. Yes or no? Right? So although we can directly go for this particular calculation also, as we know that the maximum water which is required during this particular core period. Yes or no? So we can calculate what will be the discharge for this particular value, but just to check, we will find out it for normal days also, we will find out it for core period also, right? So during normal days, right, or during complete base period, so it was given as base period, it is given to us, that is 120 days. Delta value is given to me, right? The depth of water which is required, that is given to me 12, that is 35 centimeter. I can say it is 0.35 meter. Right? Discharge value we need to calculate. How we can calculate the discharge value? We know that delta, this is your favorite formula, delta is equal to 8.64 B by D. Although this particular formula it is not needed if you can convert the particular units also, right? But try to see, in this particular formula you have to take the extra care that in which particular unit these values are. So this value we have to take in meters, this base period it is in days, and this duty value is what? It is your hectare per cubic, that is meter cube per second, right? And this D value, it is nothing but area upon discharge. This is nothing but area upon discharge, right? So for normal days, the area was also given to us, right? The area is known to us as 100 hectares. Clear? So in the question, area was given to us 100 hectares. So from here I can calculate what will be the discharge required, right? If I just replace this D with A by Q, I'll be able to find out what is this particular Q value, right? So Q value which we'll get is, it will be 100 into 0.35 upon 8.64 into 120, right? So this is 100, area was 100 into 0.35, divided by 8.64 into B value, that is 120. What is this particular value you are getting? I am just saying it as a Q1 value. This is for the complete base period, so I am saying it as Q1 value. So this particular Q1 value, we are getting it as 0.033 meter cube per second, right? So this is what discharge value during the complete base period. Now, if we talk about what will be the discharge required during the core period, so during core period, during your core period, now the time which was given to us is 30 days and depth which is required, that is your delta value, that is your 12 centimeters, or you can say it as 0.12 meter, right? Again, I can find out the Q2 value directly, right? What will be the Q2 value? It will be, area is same, so 100 into 0.12 divided by 8.64 into B. B value is what? 30 days. B value is your 30 days. What was the answer you are getting for this particular question? What was the answer you are getting for this particular question? So it was coming to be at 0.0463 meter cube per second, right? So Q2 value is 0.0463 meter cube per second. This value is 0.033 meter cubes per second. It means you will design your particular canal for this particular discharge. You will design your particular canal for this particular discharge. I hope this particular question is also clear. So just let me know in the comment box if you have attempted this question or not. Have you attempted this question and have you got the same answer for this question? Just let me know in the chat box. Yes, everyone. Also just share the session so that other student will also get benefited for this particular question. Tell me, is it clear? Have you got the same answer for this particular question? Okay. Okay. Now, again I got one particular question from your steel structures. So there is one question from steel structures. Right. So steel was also asked easy, yes or no? If we talk about the question, I think one question it is asked from the calculation of shade factor. So generally a student used to cover that part also of the particular steel structure, and also one question is from your welding, right? That is connection, and connection also student used to study. Clear? So from connection and from plastic analysis, from these 2 points you got the question, right? So I have one question from the connections, that is welded connection, and it was given as there is a particular plate, there is a plate and another plate, there is another plate connected to this, another plate is connected to this, right? So just let me know if the question is same or not, right? So this was your particular question. This particular, at these points you have done the welding, at these points you have done the welding, this particular value it was given as, it is given as 75 centimeter. And this particular value it is given as what? 50. This is also given as 75. And you have applied one particular force, or you need to find out what will be this P safe value. What will be this particular P safe value? Just let me know if the question was same or not. Also, size of welding was given to you. Size of weld was given to you 8 mm. Right? And permissible stress was given to you. Sigma permissible. It was given to you as 120 megapascal. 120 megapascal. And this particular P safe value, it was asked in kilonewton. This particular value was asked in kilonewton. Right? Now, how you can approach this particular question? We know that this particular P safe value, what will be the safe load? Safe load will be your permissible stress multiplied by area. And which area we have to consider? We have to consider the effective area of this particular welding, right? So it will be what? Sigma permissible multiply by area of weld, A effective. We know that this particular A effective will be what? A effective will be effective length multiply by what? Multiply by throat thickness, right? And this throat thickness also, we know that this will be what? This will be K into S, that is 0.7 times of this size of weld, right? This is the particular S value. This is the particular S value. Now, if I calculate this A effective will be what? It is L effective into throat thickness. What is L effective? This is 75 plus 75 plus 50. Although it used to be L minus 2S, right? You can just use this particular total length value as effective length, right? So L effective, we are getting it as 200. That is 75 plus 75 plus 50, right? So it is 150 plus 50, 200 into throat thickness, that is 0.7 multiplied by this particular value, 8 mm, right? Okay, this is also in mm, right? So what value you are getting it for? So we are getting it as sigma permissible into this is the particular effective area, right? So what will be your P value? This will be your 120 into 200 into 0.7 into 8, right? If you solve this particular value, we are going to get this P safe as 134.4 kilonewton. We are getting it as 134.4 kilonewton. Yes or no? Have you got the same answer? Just let me know in the chat box. Just let me know in the chat box. There are other questions also from other subjects, from transportation, from hydrology also there are some questions, right? So just let me know. Just let me know how was your paper. This was the particular pattern. Now I would like to invite other faculty also. I would like to invite, yes. Okay, come Sandeep sir, and Sandeep sir will be discussing the different questions from hydrology, right?
So welcome back, my dear students. I hope you have done your best in the exam. So thank you, Ankit sir, for giving me the access for let me know related to the hydrology and irrigation topics. So here, students, I want to discuss about the concepts, means whatever the questions they have asked in the hydrology and irrigation. Anyhow, one question was already explained, the base period, delta and duty by Ankit sir. So I'll be discussing more on the topics of phi index as well as the infiltration capacity. My dear students, if you have watched my video on the last moment strategy, I have given only two topics, that is infiltration, phi index, and that video is uploaded already in the 3 days before. If you have watched that video, you might have scored the 100 out of 100 marks from hydrology and irrigation. So now the first question I would like to tell you, my dear students, they have given the initial infiltration as 10 mm per hour and the final infiltration as 5 mm and what is the infiltration time or what is the total infiltration here they have given. My dear students, whenever these kind of questions are asked, you have to remember this graph, students. If you see here, the infiltration is F0, that is the initial, or you can say the initial infiltration. And if you see, the graph will be in this way. And if you see here, if I take this as final infiltration, or some people will be showing with FC also, and this is Fi. And he is asking the infiltration at a time t at 12 hours. So my dear students, and whenever these kind of problems are given, the infiltration at a time t, using the simple concept, you can say here this is FC plus, if I show it with F0, some people will show with initial or F0. Infiltration at a time t is given by this graph, FC plus F0 minus FC into e power minus kt. Okay, my dear students, where k is the decaying constant. So remember, when you remember these formulas, it would be very easy to solve the problem. So here, as they given you, the initial infiltration was given as 10 mm per hour, and the final infiltration is given as, the 5 mm per hour. So infiltration at a time t at 12 hours, first we'll write the equation for the infiltration at a time t, that is Fc plus F0 minus Fc into e power minus kt. So my dear students, the final infiltration was given as 5 plus the initial was 10 minus 5, and the decaying constant we have here is 0.5 into t. Sorry, not. Now if I see here, for infiltration at a time t is given by the formula 5 plus 5 into e power minus 0.5 t. Now what they have asked you, they have asked the infiltration for the total infiltration for at 12 hours. So if you write this 0 to 12 hour f of t dt, this is basic integration, and you can see here the integration here is 0 to 12. And what is the function of time t? So if you see the infiltration at a time t, it is given by the formula 5 plus 5 into e power minus 0.5 t. So here if you know the integration in dt, so if you know the integration of the constant with respect to time t, it can be written as 5t, and the upper limit is 12 and the lower limit is 0. And if you remember that what is the integration of e power x, it will be e power x, so 5 into e power minus 0.5 t upon minus 0.5, because into, so this will be taken as 12 to 0. So if you solve this, you will get a value of 60, this value, and this value if you solve that, 9.97 you will get. Total you will get 69.97 mm. So the total value you will be getting how much, my dear students? The total value will be 69.97, or approximately 70 mm is the answer. So I hope this solution is clear. Whenever, if you don't know anything also, as I told you, if you know this graph, the final capacity and the infiltration capacity, it is a decaying graph. So if you remember this equation, if they ask you at a time t, means integral 0 to t, the final infiltration capacity f of t dt. So this is a very, very basic question, and I hope all the IMS students have done their best in the hydrology and irrigation. Now coming to the next question, my dear students, when I talk about the next question, there was a question given. The problem here is, see, let us see the problem. I will be explaining you the problem, how easily we can do this problem also. The problem here is, they have given you a 12-hour storm, occurs over a catchment. A 12-hour storm occurs over a catchment. A 12-hour storm occurs over a catchment and results in direct runoff of depth of 100 mm. calculate the phi index. They might have asked you, what is the phi index they have asked, and they have given the question in this way. The rainfall is given here. They have given the rainfall here. On y-axis, they have provided you the rainfall, my dear students. And on x-axis, my dear students, they have given you the time. On the x-axis, they have given you the time. And the graph is in this way. And these values are given as, whatever the values here is 12. And here we have the value is 4. And here we have the value is 6. So this is rainfall and time. Now my dear students, whenever you are solving this problem, it is a very simple way of solving. So first calculate the total precipitation. So what is the total precipitation means, or total rainfall? You can say intensity of total precipitation is nothing but intensity of rainfall or into time. Or you can say here total precipitation. Here they have given you how much value, sir? Here this height is also given, my dear students. This height is also given. It is 20. So if you remember the area of this diagram, you will get the total precipitation. So what is the area? No need to do as a triangle and then another rectangle and another triangle. Instead of this, if you consider, if there is a trapezoid of height h, okay my dear students, of height h with two parallel sides A and B, what is the area of the trapezoid, my dear students? The area is given as half into height into sum of the opposite sides. So this is a very simple formula where you can do the problem. So whenever we have given this, so here what is the side? So from the diagram, it is evident or it is clear, it is 12. And from here, what will be this value? So here we have 6 and here we are having 4. So this will be equal to 2. So whenever we are talking about the total precipitation, we have the formula half h into A plus B. Very good, students. Now what is the value of h here? We have the height is nothing but 20. So half into 20 into A plus B. A is given as 2 and B is given as 12. So on solving this, you will get the solution as 140. But my dear students, what is the answer they are asking you? They are asking you the formula of phi index. So phi index is given by the formula, simple formula, that is equal to P minus Q upon T. Here the runoff depth is given as how much, my dear students? They have given the runoff depth as 100 mm. So total precipitation you got is 140 mm and minus Q is how much? Q is nothing but the runoff depth is 100. And the time, if you ask me the time, they might not give you, but in the graph it starts from 0 and ends at time 12. So the time given here is 12. So is it clear, my dear students? So what is the value you got? So the time is given in the problem clearly that it is 12. So 140 minus 40 upon 12. If you solve this, it will get as 40 by 12, or you will get 3.33 mm per hour. I hope this solution will help you. Okay. So students, when we are coming live also in the evening session, if you have any doubts in this, we will be posting the solutions in the IMSindia.com link. We will be posting that link also. You can visit our website and get the data. And we are conducting the classes offline at Jayanagar, and we have the hybrid model at Vijayawada also. So my dear students, if you are looking for the hybrid model, or if you are looking for online classes, and if you are looking for offline class at Jayanagar or Vijayawada, IMS Gate Academy, we have an excellent team of civil engineering. So you are always feel free to, it's not about joining or anything. If you have any queries or anything related to the civil engineering concepts, you can visit our IMSindia.com and register for zero fee program, where we are giving the complete free course. You have to fill your details and you can access our beautiful videos. And one more thing, my dear students, anything, if you have any query if you are interested to join in the offline center, we are having our office at Southern Circle, and you can visit our office and get clarify all your doubts. And my colleague, my teammate Pratik Mishra sir will join in 2 minutes. and see if you have any queries related to the concepts which we have discussed. And I am telling you again and again, I am really happy, students, to share you that if you have watched my last minute strategy video, which I have told clearly in hydrology and irrigation, I told only 3 concepts, students, that is phi index, infiltration, and used the word base period delta on duty, and the same questions were there here. So students, related to the transportation also, I have given you the traffic flow density and velocity. So my dear students, please be patient. Pratik sir will join in a minute.
So my dear students, let us start with some of the other questions that are there. So one of the question is there from the environmental engineering. The question says that which of the following statement is true? So this question is from environment, and question says that which of the following statement is true? Which of the following statement is true? About refuse derived fuel. RDF, right? Now once you read the question, you may find it, sir, what is actually asked? I have never heard of this statement, refuse derived fuel. But remember, we have discussed about waste to energy plant, where instead of coal, we use this municipal solid waste for burning in furnace, right? And the amount of heat generated after burning of this refuse in the furnace, that heat is used to convert steam into electricity, right? That heat is used to convert water into steam, and from steam, these turbines are rotated to produce electricity. So this is nothing but these are talking about the waste to energy plant, or a kind of alternative fuel substance which is produced from the municipal solid waste, right? So option A says that RDF can be in powdered form. Statement A says that RDF can be in powdered form. Yes, my dear students, RDF can be in powdered form. If you shred the solid waste into small fragments, right, it will going to increase the combustion of the solid waste. So whenever solid waste is shredded into small fragments, their calorific value extracted from the burning is also increases. So yes, RDF can be used in powdered form. So statement A is true. Statement B says that high heat value of unprocessed municipal solid waste, high heat value of unprocessed municipal solid waste is lesser than high heat value of RDF, is lesser than high heat value of RDF, right? So this statement is simply saying कि after burning the municipal solid waste or RDF, what will going to generate more amount of heat? So first I would like to tell you here, whatever municipal solid waste is generated in the community, from that municipal solid waste, only organic or the fraction which is having high calorific value is considered as your RDF, your refuse derived fuel, right? So if you consider the entire municipal solid waste, obviously the entire municipal solid waste will going to have some inorganic fraction which will not add any calorific value, right? So the high heat value of the unprocessed municipal solid waste is lesser than the high heat value of your refuse derived fuel. So this statement is also correct. This second statement is also correct. Statement C says that RDF can't be used in conjugation with oil. In conjugation with oil. So this statement is totally incorrect because RDF can be used in conjugation of oil. In fact, if it is used in conjugation of oil, more amount of heat is generated in the burning of this RDF. So this statement is absolutely incorrect. And option number D says that inorganic fraction, option D says that inorganic fraction of MSW, inorganic fraction of MSW is mostly converted into RDF. So here I would like to tell you, my dear students, only the organic portion, not the inorganic portion, only the organic portion of MSW is converted into RDF, not the inorganic portion. So statement D is also incorrect. So for this question, statement A and statement B are correct. It was a multiple select question of environmental engineering. Yes, thank you, Sagar. Continue with this. So this was the question from environmental engineering. Next we have a question from structural analysis. So we have one question from structural analysis. Again, it is a very easy question. I'll just draw this quickly. So a truss is given like this. This truss is having a roller support at this end. This truss is having a roller support at this end and a pin support or a hinge support at this end, right? There is load P acting at this joint. This is load P acting over this joint. And you have this arrangement. Right? Length of these spans is L. This angle is given as 30 degree. Sorry, this angle is given as 60 degree. This angle is 60 degree and this angle is 30 degree. I'll just write down name. So this is B, C, D. This is T. This is your Q. This is R. This is S, right? So these are the namings given. First of all, I would like to tell you here, whenever we need to find the deflection of a joint, thank you Vipin sir. Whenever we need to find the deflection of a particular joint, we go with the unit load method for this truss analysis, right? And the deflection of the joint delta can be taken as summation of PKL by AE. Summation of PKL by AE. So deflection of a joint is summation of PKL by AE, where P are the member forces, due to external load. And K are the member forces, due to unit load. And this unit load is applied in the direction of deflection. The point at which we want the deflection, at that point only we apply the unit load and we calculate the member forces for all the things, right? For all the members. Now, in this question, it is given that the total vertical deflection delta is equals to K. This is small k. I'll write it as small k. So this is K PL by AE, right? So this is the deflection of that joint T. This is the deflection of this joint T, right? We need to determine this value of K. Right? So for this, we need to find the P values, we need to find the p values and we need to find the k values, and finally take the summation as pkl by ae, and whatever will be the summation, from there I can very easily get this value of small k which is asked, right? Now usually whenever any conventional question is there, we start this type of question by calculating the support reaction, but this is an objective type question and it has to be handled in a very quick span of time. So how to deal with this question? First of all, just observe this frame and identify those members which are zero force members, right? So this is ST is perpendicular to this member, so this is a zero force member. Again, when I look into this joint S, for this joint S, this member ST collapses, and now we have three members meeting at a joint, out of which two members are collinear and this third member is a zero force member. Yes, Sagar, A is also correct. Okay, so for this joint C, members CB and CD are collinear, so the member force in this member CR is again 0. When you look at this joint R, so the member QR and RS are collinear, so the member force for RB has to be a zero force member. Similarly, one more thing, when you observe this joint B will only going to have one horizontal reaction, and this horizontal reaction will align with BC. So the force in this member BQ will be 0. So these are the zero force member that are there, right? Now what we have to do is, we need to just obtain the value of the member force ST and DS. If I obtain the value of the member force ST, this value of member force ST, force in the member ST, this will be equal to force in the member RS, this will be equal to force in the member RS, which will be further equal to force in the member QR. This will be further equal to force in the member QR, right? So this is the kind of line in which all the forces will be acting over the line. Similarly, if anyhow I obtain the value of member force in this member DT, so this member force will be equal to the member force for CD, and it will be equal to the member force of BC, right? So we need not to obtain the support reaction. The only thing what we want is, we need to find the force in the member ST and force in the member DT. So for that, we can have the FBD for this joint T. So considering joint T, consider joint T, consider joint T. So for this joint T, we have two members meeting. So this is my joint T. This is my joint T. Over this joint T, this vertical load P is acting, and this is the member which is inclined at 60 degrees at joint T, right? So this is force ST and this is force DT. I have assumed the direction of force ST to be tensile and force DT to be compressive. This is assumed from my side, right? Now taking the summation of vertical forces 0, so you will find that FST sin 60 will be equal to P. Now sin 60 is root 3 by 2, so FST root 3 by 2 is equal to P. So FST is equals to 2P by root 3. FST is 2P by root 3. Similarly, if you take the summation of vertical forces 0, summation of horizontal forces 0, you will find FDT will be equal to FST cos of 60 degrees. FST cos of 60 degrees, right? So FST is 2P by root 3, this is 2P by root 3, and cos 60 is 1 by 2, so this is P by root 3. So FDT comes out to be, P by root 3, and this P by root 3 is compressive in nature. This P by root 3 is compressive in nature, and this FST is tensile in nature. This is tensile in nature, right? So I can easily make a table to get the value. I'll write the members, then I'll write P values, then I'll write K values, and then I'll write length. right? So I'll have these members. For the member, I'll start with member QR. So member QR, then I have member RS, then I have member ST, then I have member BC, then CD, and then I have DP, DT, right? So these are the members. So the P values for this QR, RS and ST is equal, and it is equal to 2P by root 3 as FST, as you can see here. Force QR is equal to force RS is equals to force in the member ST. All these three are equal, right? So top three are equal. So this is equal to 2P by root 3, and all these are tensile. So this is 2P by root 3. This is again 2P by root 3. This is again 2P by root 3. Now talking about BC, CD and DT. As you can see here, force in the member BC is equals to force in the member CD is equals to force in the member DT. We know the force in the member DT, force in the member DT is P by root 3 compressive. So all these three are compressive. So this is minus P by root 3, minus P by root 3, minus P by root 3. So these are the P values, right? Now in order to obtain the K values, the only thing that you need to do is just replace this P by 1, because this can be the forces or this will be the K values, because we need to apply unit load here itself. We are given with the deflection of this point D or joint D, right? So here itself in the same downward direction I need to apply the unit load. So the same forces that are produced due to this load P, same amount of forces with the unit load will be produced. So the K values can be written directly by just substituting the P as 1. So the K values I'll write directly. This will be 2 by root 3. This will be 2 by root 3. This will be 2 by root 3. This will be 2. This will be minus 1 by root 3. Again minus 1 by root 3. Again minus 1 by root 3, right? So these are the P values and K values I got. Now talking about the length. For this member QR, RS and ST, the length are L, L and L. So I'll write the length of the member for first three as L. This is L, this is L, and this is also L. Now talking about the remaining three bottom members. So L cos 60 will be the length of the member DT. Same will be the length of the member CD, and same will be the length of the member BC. So length of the member DT will be L cos 60. And what is L cos 60? L cos 60 is nothing but L by 2. So the length of member DT is L by 2, which is equal to length of the member CD, again L by 2, which is equal to length of the member BC, which is again L by 2. So all the length is L by 2. So this is L by 2, L by 2 and L by 2. Now the only thing is I need to take the summation of PKL by AE. So just multiply P values with K values and L and divide by AE to get this PKL by AE. Finally, we can take the summation. So this comes out to be 2 by 3, 2 PL by 3. So this is 2 PL by 3. This is 2 PL by 3. This is, this is 4 PL by 3. 4 PL by 3. Again, this is 4 PL by 3. This is also 4 PL by 3. When you multiply this, so this is P by 3, so P by 6. So this is P by 6, P by 6 and P by 6. So finally, when you take the summation of all of these, so summation of PKL by AE, summation of PKL by AE, so I need to divide by AE also. This is 3AE, this is 3AE, this is 3AE, this is 6AE, this is again 6AE, and this is also 6AE, right? When you take the final summation, you will get the final answer as 4.5 PL by AE. PL by AE. So this is my final answer. So here the small k value is Small k value is 4.5. So for this question, option with 4.5 is the correct answer. Option with 4.5 is the correct answer. Hopefully you have done this question correctly. This was one of the easiest question that was asked in your examination from structural analysis, right? So this was a question from structural analysis. Moving on with one more question of structural analysis, which says that you need to identify the unstable structures. You need to identify the unstable structures. So first a beam is given. And this beam consists of a hinge support at the start. This beam consists of a hinge support at the start. Then you have an internal hinge, and after that you have this roller support in the middle. So this is a roller support in the middle, and then again you have a hinge, and then you have a guided roller support. You have a guided roller support, right? So this can be analyzed by using the degree of static indeterminacy, but there is one easy method for analyzing the unstability of this, right? You need to just apply one load like this over this member. You need to apply one load, or you can apply the load over this hinge, right? Apply the load over this hinge. So this member will going to deflect like this. So as you can clearly see, there is the formation of mechanism for this beam. Hence, this is an unstable structure. This is an unstable structure. This is an unstable structure due to the formation of mechanism. As you have applied load, it has deformed by a huge amount, and that too in a permanent fashion, right? So this is an unstable structure. Next, if I talk about another structure, so a truss is given like this. So a truss is given like this. So this is your hinge support, and again you have a roller support here, and you have a roller support here, right? So these two are the roller supports that are given. You need to analyze this for stability. Now, one common criteria for stability is if all the forces are concurrent at a point, then that structure is an unstable structure. Because if for that structure you rotate or apply any moment, that structure will going to rotate by a huge amount, right? So as you can see here, there is one support reaction, there is one horizontal support reaction, there is one vertical support reaction, there is one vertical support reaction for this lower support, and there is one horizontal support reaction like this for all these supports. All these support reactions are concurrent at this point. So about this point O, there can a rotation of this structure that can happen. So again, this is an unstable structure. This is an unstable structure. This is an unstable structure. This is an unstable structure, right? Now moving on with the third figure that is given to us. The third structure which is given to us is, we are again given with a truss, simply supported truss like this. Truss has two compartments. As you can clearly see, on application of the load, this portion can collapse diagonally. This portion, the first block of the truss can collapse diagonally. It can collapse. It can collapse diagonally. It can collapse diagonally. There is no restriction diagonally for this support, for this part of the truss, right? So this can collapse diagonally, hence it is an unstable structure. Hence it is an unstable structure. So all the three structures that are given to us are the unstable structure. All the three structures that are given to us are the unstable structures, and accordingly you can mark the correct option, right? Moving on with the next question. Next question is of environmental engineering, and it is one of the easiest question that can be framed. Question is framed where you are given with the discharge of wastewater. Discharge of wastewater of an aeration tank is given as 0.5 meter cube per second. So this question is from activated sludge process. Activated sludge process. This question is from activated sludge process where the discharge is given. Inlet BOD is given as 150 milligram per liter. This is given as 150 milligram per liter. Your MLSS concentration in the aeration tank is given as 2000 milligram per liter. 2000 milligram per liter. Next, F by M ratio is given as 0.2 milligram per day. Milligram per day, right? So this is the F by M ratio given for an activated sludge process. You need to find the volume of the aeration tank. Find the volume of aeration tank. You need to find the volume of aeration tank. You need to find the volume of aeration tank. Now this question is simple. It was a direct formula based question for the activated sludge process. What you need to do is, this F by M ratio is nothing but amount of food entering into the system, that is Q naught into S naught, divided by the total volume of, the total concentration of MLSS present in the aeration tank. So the total concentration of MLSS present in the aeration tank is the volume of the aeration tank multiplied by the MLSS concentration X, right? Now while substituting these values, you need to keep a quick check on the units which are substituting. Here the volume has to be calculated in meter cube. The volume has to be calculated in meter cube. So I'll just substitute all the values. So F by M ratio is given as 0.2 milligram per day, right? And here you can see it is in meter cube per second. So I'll better convert this day into second. So this is 0.2 divided by 3600 into 24. So this is milligram per second, right? So this F by M ratio is milligram per second. Now talking about discharge, this is given as 0.5 meter cube per second. So converted into liters, this will be 10 raised to power 3. S naught is given as 150 milligram per liter. So this is 150 milligram per liter divided by, now here the volume of the tank is in liters. The volume of the tank is in liters multiplied by the concentration of MLSS. So this comes out to be 2000 milligram per liter. So whatever volume you will be getting from this, you need to divide it by 1000 to get the volume of the aeration tank in meter cube, right? So the volume of the aeration tank in meter cube that you will be getting, so whatever volume you will be getting from here, you need to divide it by 1000 to get the volume of the aeration tank in meter cube. So this comes out to be 16200 meter cube. So volume of the aeration tank comes out to be 16200 meter cube, right? So this is the correct answer. This was a direct formula based question which was there. Next, the question of environmental engineering is, volume of the flocculation tank is given as, volume of flocculation tank is given as 2800 meter cube. At temperature of 15 degrees Celsius, the temporal mean velocity gradient G1 was kept at 100 per second. And at temperature of 15 degrees Celsius, the viscosity, the dynamic viscosity of the fluid is given as 1.139 Newton second per meter square. So this was the data given at 15 degrees Celsius. The temperature is reduced to 5 degrees Celsius. The temperature is reduced to 5 degrees Celsius and the value of dynamic viscosity at 5 degrees Celsius is given as 1.518 Newton second per meter square, right? If we supply the same amount of power, then what is the change in the temporal mean velocity gradient that will be happening? You need to calculate the percentage change in the temporal mean velocity gradient. Understand this very carefully. When the temperature is reduced, you can clearly see the viscosity of the fluid is increased, and for same amount of power supplied into the aeration tank, now this temporal mean velocity gradient or the intensity of mixing, it will going to reduce. So on decreasing the temperature due to increase in viscosity, the intensity of mixing will going to reduce. That intensity of mixing, by how much amount is reduced, we need to calculate that. It is again a very easy question. So if anyhow I can get the value of G2, I can easily get the percentage change in the temporal mean velocity gradient. So for calculating the temporal mean velocity gradient, we have one simple formula. G is equals to under root P upon this V into mu, right? This is the simple formula for calculating the temporal mean velocity gradient. Now power at 15 degrees Celsius is kept same as power as 5 degrees Celsius. The power of the shaft is kept same. Now just substitute the value of power at 15 degrees Celsius. This will be equal to G1 square V into mu1. This will be equal to G2 square V into mu2, right? This will going to save your calculation, a lot of calculation. So this V and V cancels out. Substitute the value of G and mu1 to get the value of G2, right? So G1 is given as 100. So this is 100 square into mu1, it is 1.139, and G2 you need to calculate. So G2 square into mu2, this is 1.518. This is the value that you will be getting. From here you can calculate the value of G2. So the value of G2 comes out to be, something 86.62. This is 86.62 per second. So this is the value of G2 that is coming. So the percentage change in temporal mean velocity gradient is is equals to nothing but G1 minus G2 divided by G1 into 100. So this is the percentage change. So G1 is given as 100, G1 is given as 100, G2 is 86.62 divided by 100 into 100. So this is the percentage. You can quickly calculate this. Comes out to be, this final answer comes out to be 13.38 percentage, 13.38, or you can just check the calculation, right? So hopefully you people have attempted the civil engineering paper very happily, because all the things that are asked in examination are directly from our classroom program, right? They are directly, some questions are directly from our notes that are asked here in your GATE examination of 2023. So we will begin our analysis of afternoon session at 5:30 p.m. onwards. So join us live at the same YouTube channel of IMS GATE Academy. And my dear students, for all the new aspirants that will be facing GATE 24 or 25, I would like to tell you, just visit our website IMS GATE Academy. There you can find a login of zero fee program. By logging into Zero Fee program, my dear students, you have direct access to the free content, which is around 120 hours of concept videos. There are chapter tests, there are subject tests, there are free gate papers that are available to you. So you can just avail all those content free of cost by visiting our website of IMS Gate Academy. So this is all from the analysis of the forenoon session. Hopefully you have enjoyed the solution, because we believe in authenticity, we believe in credibility, and whatever solutions we give to our students, we make and we confirm it to the best level that no error is there. We provide the error-free solutions to most of our students. Thank you so much everyone for joining us live. We will begin our analysis of the afternoon session shortly. So continue with IMS Gate Academy. Thank you for watching.